And the voting system is a bit dangerous in itself, because with you lot, it has been known to be hacked a little bit, and you get huge blocks of votes coming in, and yeah, that's interesting in itself. There's the Crash and Burn prize, which is for the demonstration that goes most horribly wrong. There's usually a bit of competition for that. And then lastly, there's a prize, it's called the Swan Prize, for the demo that appears to be completely without complication or difficulty, but it's just technically brilliant. And so we introduced a new prize called the Swan Prize for that. If you want to do a dangerous demo, remember it's only 3 minutes. Come and find me. Even if you don't want to do a demo, I'll come and find you. And I guarantee that there are probably half a dozen people in this audience right now who had no concept of doing a dangerous demo, but you will do one. So come and find me afterwards. So thank you, Daniel.
Okay. And a small announcement for Randy before the next break. He wants to give away.
Yeah, this is a little bit embarrassing, but you folks, some of you know about the Sit Vicious t-shirts. And I'll show you one, but I wasn't prepared just this minute. Here's a guy. I only have one, and it's medium size, and I'll pass some cards around to those of you who want to have it. If it's not for you, it could be for your spouse or your significant other. But it's a rather small number, so we'll do that before the next break, right?
Okay, and yeah, Kamailio t-shirts, also some giveaways on the back. We'll put more on the registration desk, as everyone was registered already, and we'll have more space there. Now, the next speaker, or the first speaker, will have the Carsten, and while he's gonna setting up his stuff, I'm gonna present a few words about what he's doing. So if you watch Kamailio project, probably you notice that a lot of commits and modules related to voice over IP and voice over LTE, IMS, diameter, were coming from Carsten and his company NG Voice from Hamburg. They are doing a lot of cool stuff with deploying Kamailio on these next generation networks environments. He has been with the project for a very long time and supporting Kamailio World as an event a lot. And you can find him and his team in the exhibition area with some demos, so whenever you get a chance, just approach them. They have cool stuff to show. Carsten, thank you for coming, and now the first workshop about Kamailio IMS Vault End. Thank you.
Thank you. Thank you for having me here. It's, as always, exciting because this year we have some very special announcements actually to make, which will be really maybe a little bit surprising. What we're going to do today. Okay, first of all, we're going to look a little bit what happened last year. What happened last year on the Kamailio project, and especially on the IMS part of it. Then we will be looking a little bit into how's the architecture of IMS. Just a quick overview. Those of you who have been here last year, they will probably recognize the slides. And then, of course, we will do some basic installation and configuration of a mobile network. And last but not least, we're going to look a little bit into provisioning and configuration of everything. This is basically our goal for today. Just a quick question. Who was here last year for my workshop on installing IMS? Did somebody try it? Did anyone have success? Okay, at least one, at least one. Okay. First of all, let me start a little bit why we want to do VoLTE. And this is usually something that most people don't understand. First of all, if you're a mobile operator, you have one big cost point, and that's the spectrum. You really have limited spectrum. You cannot get as much spectrum as you want. If you look at T-Mobile US, they paid a fortune on getting new spectrum. So we really have to be sure to use that spectrum really efficient. If you take a traditional 2G, 3G network, then okay, you have 40% used for voice in that 2G, 3G network, which is really quite a lot. If you switch to voice over LTE, it's down to 10%. This is really a huge benefit. And of course, one really big point is that if you build a new 4G network, it's tremendously cheaper than building anything that you had before. This is basically the reason why if you see new networks coming up, they will be pure LTE networks. No one is going to build any more 2G, 3G. It's simply not worth it. It's really a cost factor that's driving VoLTE. If you look at the VoLTE, at the voice over LTE infrastructure, then you will notice that it's basically IMS. And IMS has been around for like 30 years, I don't know, for really quite a long time. And it never really took off because, okay, people were thinking, okay, it's a bit complicated, it's a little bit, yeah, why do we need this, why do we need that? And but with voice over LTE, it has become the de facto standard for voice over LTE. There has been some attempts to do it on different ways, like voice over generic access, Volgar, or something similar, but VoLTE is currently definitely the way to go for mobile networks. If you take, for example, Germany is always a good example, because one other topic that's really driving mobile operators is to have converged network. If you go to basically any big operator in Germany, even on the fixed line you will get IMS, and this is basically because you want to have one network for all your services. So let's look at what happened last year. Okay, last year I've been talking about that we added an online charging server, because you can do a lot of fancy stuff with Kamailio and the IMS infrastructure, but you definitely also need charging. A network is nothing worse if you can't do charging on it. One more thing that we added quite recently is a generic diameter server. A generic diameter server which will actually handle any sort of diameter requests, and based on this we've developed and deployed a new home subscriber server. A home subscriber server is the central profile database for a mobile network, which holds information like what are your credentials, what are your, how does your service look like, and all kinds of stuff like that. And also we've added a new management interface, which from my personal opinion looks quite awesome compared to everything we had before. Based on my question which I asked before, you see only one person in this audience, and I believe this is a very technical audience, really ever attempted to install IMS. And one thing that we did is that we overhauled, that we improved the installation process, that we really make sure that it's really getting easier and way easier to install IMS based on Kamailio. And of course, last but not least, always bug fixes, bug fixes, bug fixes. That's yeah. As it's a little bit like every software. If you take it to more production networks, then you find things that you didn't even think about before. So continuous bug fixing. This is one of the slides I had last year, and this basically shows the basic IMS infrastructure. And a lot of things you see in the IMS world, in the IMS, in the way you talk about IMS, is that you see a lot of things that you probably know under a different name.
Yep.
Just as an example, if you take the proxy CSCF, which is the entry point to your mobile network, then it's nothing, it's a little bit more than an outbound proxy, but still it's some sort of outbound proxy. If you take the interrogating CSCF, which is another central part of the IMS world, then this is nothing more or nothing less than a little bit intelligent load balancer. So it's really, yeah, load balancer, but a little bit more sophisticated. The serving CSCF is a registrar, is a core routing server. It's nothing really. It's still a little bit more flexible, but anyway, it's still a registrar and it's still a core routing server. And then, of course, we've got application servers, and all of the protocols we are talking within the network, we're talking diameter. Why do we talk diameter? Because does anybody know what diameter is compared to radios?
Twice.
Yes?
Twice is good.
What? Diameter is a more modern protocol, I guess, and more flexible.
Exactly.
Yeah, twice is good.
Twice is good. Why twice?
Diameter is twice the radius. That's the correct answer. So you can do quite a lot more on the diameter protocol than you could do on the radius protocol. One thing that you really need to do on a mobile network, and this is something different to, I would say, most other OTT apps or to any fixed line deployment that we have a lot, is that you need to do quality of service. And quality of service on a mobile network is really crucial. You really need to do quality of service. One reason is basically if I take a default mobile network cell, then you might see that it's connected using a gigabit link or something like that, and all the users on the mobile network will share this gigabit link. If you're 10 users or 100 users or 1,000 users, they will all share exactly the same gigabit link. And as a result, voice may really suffer if you don't do quality of service properly. This is really a big topic for mobile networks. If you do quality of service on the mobile network, you really get a guaranteed bandwidth. You get a guaranteed bandwidth for your voice service, and it really gets the quality it needs. And basically, I always say, if you do a VoLTE call, then yeah, we don't care about Skype or anything else that might be on the mobile network as well. We own the network, so we control the network, so we can say that our calls have priority. Okay, if we want to install IMS and Kamailio, then we've got some really basic requirements. At the moment, all of our deployments are either Debian or Ubuntu. We've got some deployments on Red Hat, but that's, I would say 95% of the deployments are Debian or Ubuntu, so that's what it's optimized for. And quite frequently, if people start with IMS, then they skip the name server. They say, okay, we've got a local hosts file and it's really, yeah, it should work as well, shouldn't it? No, it won't. We really need a DNS server, and it really has to be properly configured. Having a real DNS for IMS is a must. And of course we will need a database, which most commonly is MySQL, but it could be basically any database. We basically use the database for stuff like persisting data on the serving CSCF and on the proxy CSCF, and we use the database for keeping profile information, stuff like that. But yeah, that's why we need a database. On the LTE network, this gets a little bit more complicated. This really gets a little bit more complicated. Because one thing that most people don't know is that if I take my usual mobile phone, like my Samsung, for example, then it will have a dedicated channel only for the signaling. It's really separated user traffic, like, let's say, Skype, or and the IMS signaling. So even, it's really like you're having two different channels on the mobile handset. And if you really want to do voice over LTE, you need to have two different APNs. One reason for this is basically because you want to do a different, you don't want to charge for the mobile traffic, and you want to, and you also want to allow voice calling if mobile data has been turned off, stuff like that. There's a thing called PCO options in the mobile world, which is a little bit, I would almost compare it to DHCP. You connect to the network and you get some options in reply. I think the DHCP protocol also allows assigning zip servers. I've read it somewhere in the spec, but I've never seen it in real life. But this is something that's definitely done on the mobile network. And then, of course, you should do some quality measurements, like, for example, you have 9 different levels of quality on the mobile network, like QCA9 is best effort, but no packet loss, and QCI5 has a little bit higher priority, but still we can tolerate a little bit packet loss. And then we've got QCI1, which is definitely the best. We need all that we can get, but we tolerate some packet loss. So for the IMS APN, you should be on QCI5. Okay. If you're not running mobile networks, that's probably something you don't know. The mobile network needs to indicate, it's really needs to indicate in the setup, in the registration, that it will support voice over packet switch. Okay. I think I dig a little bit too deep into LTE networks recently. Another thing that you need is a device. And since IMS is basically just zip, it's purely just zip, you can actually connect any sort of zip-capable device to your IMS network. It can be a desktop phone, like a SNOM phone, or a DGIOM phone, or anything like that. It can be a OTT app, like Zoipra or Acrobits, or something like that, or it could be a pure DSL modem. Basically, any device that can speak zip can connect to your IMS platform. If you want to do VoLTE, if you want to do mobile networks, it's a little bit more challenging. You need a VoLTE-enabled phone. And, you know, basically, Qualcomm, which is the main manufacturer of 4G chips for mobile phones, they've been supporting voice over LTE for decades. Like, more than 10 years, definitely. But usually it's disabled on the phone. So if you just go to the next shop and buy a VoLTE-capable phone, you will probably see that it doesn't automatically work on the 4G network. The device manufacturers, like Samsung, just to give an example, they will actually store the information what networks support voice over LTE in the firmware. So you need to make an agreement with Samsung, for example, to get them to enable voice over LTE on the phone. All manufacturers of phones, they offer engineering versions, but they're kind of hard to get. I have to admit that basically you usually get them through operators, and they only give it them to operators. They don't give it to developers, especially not to open source developers. There's one a really nice example, and I really have to mention it. And that's actually the OnePlus phone. The OnePlus made in China, which is a really great phone. And this phone has voice over LTE enabled out of the box. Really, it's plug and play as it should be. But that's unfortunately the only phone that has voice over LTE enabled by default. Okay, so let's get started with the IMS installation. First of all, we need bind and MySQL. And we definitely need a zone file to keep it all up and running. In our repository, we've got a sample zone file for the developer test network defined by the 3GPP. And it's basically just copy that file to your local hard drive, configure bind to do though, and restart bind. Probably you want to change some IP addresses, but that's really about it. And you definitely need MySQL. So, in order to make it more easy to install IMS, we've created configuration packages for almost everything. And one reason is basically because one thing is we wanted to make it more easy to run updates. Okay, if you change something, then it should be something like apt-get update and apt-get upgrade to get the latest version. And in order to set up the repository, you can actually download a simple script. Just copy this. And oops. Okay. Wait. It's not really that. This is a little bit unexpected. Okay. Change the appearance, change it. The size, something like that. Doesn't really look better. Okay.
Change colors, black to white.
Yeah.
Colors.
Ah, ja. Okay. I guess you just have to believe me. But anyway, all I'm going to do is basically download my script, change the permissions of the script, make it executable, and run it. If you look at the script, you will see the script does nothing special. It basically just downloads the repository. It will install the configuration key, the apt-get key, and will basically run apt-get update. So really nothing special. takes a little second. This is live. So once the script has run, I can really simply go apt-get install IMS PCSCF, IMS ICSCF, IMS SCSCF, and we take the tilde suite CRM. Basically just install some really basic packages. Yeah, download 260 megabytes. Okay, and basically everything that follows behind that is really done in some, I would say, almost nice installer. So you get asked quite a lot of questions, like you need to define the country code you're running in. Default is fine, 001 for the test network. You need to define what networks you're listening on. Okay, let's take that one. We've got IP version 4, IP version 6. We need to define the host name. Our new HSS, which we haven't really put on GitHub yet, but we will do this later this week, actually has two modes of operation. One mode of operation is using a standard REST API to execute information between the diameter processor and the worker process. And another way is actually using a RabbitMQ. Each one of those modes has specific benefits and drawbacks. Okay, so just as an easy installation, we use a REST API. So it's again just another questions with a lot of example questions. Okay, we want to allow XML RPC, and even the diameter configuration has been fully automated. Like, okay, what network, what IP address should we listen on? What's the port for diameter? What's the peers we should listen on? Okay, next one. And it really goes on and on and on like this. What protocols are we listening on? Really everything that you need to configure, you configure it using graphical or at least some sort of installer which should guide you through the installation. Okay, we've even got, of course, we've got native integration into Homer, which is really nice. Even this is configured using the configuration file. So in theory, it's really a little bit in theory, you should not need to touch any of the configuration files. It's really, install the package and go have fun. Okay, got some database set up, create database, we've got, what's the root user? Proxy CSCF, it's really goes on and on and on. What you will see, for example, here is that on the proxy CSCF, since it's where we're trying to do some converged network, you can actually run UDP, TCP, TLS, WebSockets, and WebSocket, TLS on the proxy CSCF. So it's really, okay, we want to send it to an SBC, stuff like that. Really, some of the things we implemented last year, like the Rebel support for roaming. Okay. So I guess you get the idea that the installation of all the components is really, really straightforward. Once everything is installed, you can actually, you get actually two sorts of interfaces towards management of the platform. One is standard REST API to do some requests. You can basically query any information you see in the management interface, also using REST, which is might be interesting for integrating with other third-party services. And Alternatively, you also get, I would say, a nice looking management interface. And the management interface is really purely about doing everything, almost everything you can do on the REST API. So, you can manage subscribers, and you can actually, for example, you can. We really try to simplify all the things you could also do, for example, in the Fraunhofer OpenHSS or something like that, but we try to make it a little bit more understandable. To make it a little bit more easy, actually. For example, this management interface also allows you to configure your SIM cards, to configure your IMSI range, to configure your identities that belong to this particular SIM card. Because one thing that you need to know about mobile networks, that if you have a SIM card in your mobile phone, it doesn't really contain your phone number. The phone number is associated by the network to your phone and not the other way around. So you really need to assign the phone numbers to your SIM card, and this should get you up and running quite easy, quite quickly. As part of the IMS platform, a part of the ecosystem, we also got a whole bunch of supplementary services. And the supplementary services is really, okay, you've got all the basic call features that you want, which is, for example, we've got some binding parameters, we've got all the call forwarding settings, we've got barring, we've got anonymous call reject, basically anything that you would typically need to run a really voice service out of the box with Kamailio and IMS. Even though I speak a lot about mobile networks and I speak a lot about voice over LTE and stuff like that, you always need to know that IMS is a voice network, and running voice over LTE is just one particular service you're running on the IMS platform, but it's basically designed to run any kind of voice service. So we've got we use this quite frequently also on fixed networks. It's really it should be one network for anything you want. You see the management interface for the IMS and for the HSS is rather complex, but it's we tried really to replace anything. A home subscriber server, which is a crucial part of your mobile network or even of your fixed network if you're running IMS. We really try to replace this with Kamailio and open source components. And for example, we've got all the service profile configuration. The service profiles is basically a little bit like you're defining what kind of services you support for your subscribers, what kind of services you run for the users. And for example, you need to define some trigger points. Trigger points are usually like, you're defining, okay, I've got a zip method invite and I want, if this trigger fires, then I want to run a specific service. Like in this case, I want to run a basic voice service. Probably the best example I have is the presence trigger point, where you basically find, okay, I've got a method publish, and I've got in the event header the tag presence, and I'm in an originating session case, then I want to forward this request to my presence application server. And you get this actually quite a lot for subscribe, for anything.
Key variables for your SIM cards in there. Because rather usefully, I've brought a few SIM cards for you to put on your network later.
Okay. Okay, one challenge you usually have on mobile networks is that you use the same cryptographic keys for both the network authentication, for connecting to the mobile network, and for connecting to the IMS. So this is one reason why you might need a dedicated home subscriber both for mobile and both for IMS. You need to provision the cryptographic keys on our HSS. That should do.
We'll try it later.
Okay. More questions? I think, yeah.
You mentioned about MTEL. Do you also have the application server also supporting MTEL?
We have an application server for voice services. If you, well, there's a specification on what voice services you should have. This is IR92, for example. And it mentions all kinds of services that you should run for complete Volta. And our MMTEL currently supports all the features except two. And one part that's missing is the multi-party conference, because if you take a standard zip desktop phone, for example, or if you take a standard VoIP app like Zoiper or anything like that, then if you make a multi-party conference, then you will actually see that the phone does the mixing. You basically, for the network, it does look like, okay, we've got several calls coming to the phone, and the phone is mixing, and we don't really care about what's happening on the. For us, it just looks like two dedicated calls. On voice over LTE, you don't want to do this. You want to save bandwidth, and you don't want to have, like, if you're running a 5-people conference, you don't want to have 5 calls on your mobile handset, because that would simply use bandwidth. So what's a mobile network, what you should do on voice over LTE is basically that you make an outbound call to a conference service, which is an application server, and then you should basically transfer all the participants of the voice call onto that application server. This is doable with XAMPP and FreeSwitch, but we haven't really integrated this part because it's a bit complicated. The second thing that's missing, and that's purely because, honestly, lack of time, that's the UT interface. I doubt anybody in this room knows what the UT interface is. Ah, okay, at least one. The UT interface is basically XCAP. XCAP for provisioning services. You can actually run XCAP to configure your call forwardings, to retrieve your call forwarding, all kinds of services. It should not be really hard to add a UT interface, but yeah, it's basically missing due to lack of time. This is all the features we are missing according to IR92. So I think almost feature complete. Not complete, but fine. One thing I always need to mention, when we are talking about IFS, and we are talking about all sorts of interfaces and reference points. If you're talking IMS, then you need to know zip, you need to know maybe a little bit diameter, and you need at least to understand what the diameter protocol is, and everything else is just a different name. UT interface is a good example. UT is XCAP, and Kamailio has done XCAP for also decades. ISC interface, okay, sounds a little bit more strange, but again, it's just zip. It's zip with a few extensions. So it's really, if you talk to mobile operators, you might come across, they're talking about the RX interface, stuff like that, but don't let the bastards get you, it's just diameter. So it's really just diameter. It maybe sounds a little bit too easy, but it's really nothing black magic. Everybody is boiling with water. More questions? Yeah?
What about emergency calling with your IMS solution?
If you, it's one of the things that we're currently adding, and it's a little bit currently you have to know that, for example, most of the networks we're operating in with open source IMS right now are, I heard once people say, okay, well, we've got emergency calling, but even if you call there and if you reach someone, it's not sure they're coming. So at the moment, we just handle them as regular calls. You may know, for example, that the Fraunhofer OpenIMS core explicitly had an emergency CSCF. And probably this could be my presentation for next year, besides legal intercept, which we also have to implement right now. Yeah?
What about the geographical restriction? What is your solution when you goes to some operator that needs to have a geographical restriction? Use cases, for example, I can make a call here in Berlin with physical phones, okay?
Yeah.
But if I go to Munich, for example, I do not be able to place that calls.
Okay. This is rather easy because this is nothing we have to take care about on the IMS network itself. Basically, if I wanted to implement something like that, I would probably do it on the mobile and say, okay, if I'm in Munich, I don't get the IMS APN and I don't indicate voice over packet switch support.
The question on this is related because on your IMS topology, you also be integrating with the Access SBC vendor, right?
What?
The Access SBCs, the Access Session Border Controls, which are the front end of your SIM network.
Yeah.
In terms of non-trusted networks to your trusted networks.
Yeah.
And there is also a diameter interface, the E2 interface, which must be used by the Access SBCs or the proxy SBCs, okay, your proxies, that will contact the CLEF, okay, entity. And my question is, do you have any kind of integration with the CLEF vendors? This is a new thing. You don't need to have faced these actions in your projects. Okay.
At the moment, we are purely driven by demand, and the demand didn't come up yet. What you might see in the near future is, for example, we have the RF interface for offline charging, which might be going to the charging triggering function, but yeah, as long as nobody requests it, we don't really implement it. Okay. No more questions? If you want to see everything live, we have a presentation outside tomorrow or the day after. Yeah. So that's it from my side, I guess. If no more questions are asked.
Interesting.
IMS in minutes.
Okay, so we have Giacomo. The next workshop, which will be about the SIP capture. Probably many of you have heard of Homer SIP capture. How many of you? Okay, Giacomo, we can have a break. Everyone knows. Okay, now you. Yeah. So. Homer, and if you search on the internet and if you are using Puppet or so, he has a couple of good tutorials of deploying Kamailio and also Asterix free switch with Puppet and other automatization tools. Not to keep it, so this session, then we'll have Randy giving away a crazy t-shirt and then a short break just for coffee and preparing for the last 3 tutorials. Giacomo, thank you.
Which you probably know as well. We're expanding the RTC voice offering, and of course Kamailio and Homer are involved. The reason why I'm here is that Homer is used for basically in every project I've been working on, and so I thought, since I was contributing small improvements and patches, I thought of being a more stable collaborator of the project. And by the way, so the main subjects in the projects are, as you know, Lorenzo Mangani and Alexander Bovikov, and you will see Alexander on Wednesday, and with his presentation, and probably around since tomorrow, starting from tomorrow. Lorenzo is online now, so if you want to connect, there will be a live interaction there. So anything related to the workshop as well, you will find him and the rest of the community. And there's also Federico around, and Alfonso made some contributions to the project. So feel free to approach us and for questions. So the need for Homer, I think it's clear for everybody. We need, when we deploy VoIP and RTC infrastructure, we need to be able to monitor and know what happens. And we have to do it typically with platforms that are experiencing low traffic, very high load, so we need to deal with it in an efficient way. And the good thing about Homer is that it's already integrated into the main applications in the area. So basically it comes from the integration with the open source applications that you are probably already using comes for free. We'll see some examples, but of course Kamailio itself it can interact directly with Homer natively. And of course we have also OpenSIPs and FreeSwitch and Asterisk and RTP engine, and in some way also Janus. And it would be an interesting case for the future. For anything that doesn't speak natively with Homer, there is Capt Agent, which is a sort of capture agent that can filter and basically packetize the packets for Homer so that they can be consumed even if the application that is produced in SIP is not able yet to talk directly with Homer. And in some cases we saw, in some installations, the flow was also encapsulated and needed special treatment, the CAPT agent can do that, can encapsulate the traffic and send it to home. We'll also see some examples of something that it's not SIP related, but it's more oriented on the events, like RTCP events and logs that you may want to correlate with the SIP calls anyway when you're doing your troubleshooting. So the key features are that it's an open source project, so it's also very easy to extend and adapt due to the technologies that have been used. And it's relatively easy to deploy. We'll see some examples later on, and can scale to very high load of traffic. So we can say it's carrier grade. There is also a cloud version for people that perhaps want to try it out, and without an installation in the premises, they can play with it, they can get more familiar, and then decide to go to the hosted configuration. So the applications communicate with Homer, which is the collector and aggregator of information, through a dedicated binary protocol, which is called HEP. And we developed also a dissector for Wireshark. So if you are troubleshooting your platform and seeing HEP traffic, you'll be able to see in Wireshark exactly what's flowing to your Homer installation. So Kamailio is part of Homer as a collector of data, but it's also, of course, the producer of data, in particular for SIP signaling. And the main module are SIP trace and SIP capture, and there is the equivalent for OpenSIPs as well, with a little bit with an additional management for the specific HEP protocol in a separate way. It comes for free with FreeSwitch as well in the Sophia library. So it just needs to be configured, and the same for Asterisk and RTP engine, and also for SNGraph. So if you're using any of these applications, it's just a matter of configuring them in order to produce data for the capturing tool. For what concerns external support, there has been an interesting project involving Janus, because Janus now has a new events management system, and what we wanted to do was being able to correlate these events with actual calls, while Homer it was designed initially in a more SIP-centric way, let's say. And for anything that is not SIP specific, with FreeSwitch, by integrating with the ESL, it's possible to get the events, which are many and can be filtered out and be sent to Homer and be correlated as well. And in a similar way for the CAPT agent and also RTP agent. Anything that is not supported yet by the applications can be seen on the network and can be traced and packetized and sent to Homer. So there is a plethora of libraries that you can use in your clients. So if you want to build your own client, or if you have to modify one, there are several programming languages covered. The protocol per se is very simple. We'll see it later. So it was easy to expand it in various languages. So the architecture is simple. So we have the producers of SIP signaling or other events, which are your applications, and then Homer itself, it's basically one collector of data, which is, in our case, is based on Kamailio, which writes on a database, which could be MySQL or Postgres, and it exposes an API, which can be used directly, but it's typically used through the GUI, which is also part of the project itself. And so being PHP based, it's easy also to customize the API for any need. And also it's possible, there are cases where you may want to access the database directly without even passing from the API or GUI. And of course it's possible because of the technology involved. And since there is Kamailio processing data there, and the logic will be based on Kamailio CFG as for your applications. So It's also possible to send the data directly to other collecting systems like Elasticsearch, for example. And we saw an example, I think, last year with Kamailio using Federico's HTTP async client module to send data to Elasticsearch for indexing. There can be various types of data. Of course, SIP signaling, but also RTCP and RTCP extended reports. And plus also quality of service reports that are sent by some applications at the end of the call, and WebRTC and RTCP events. All these can be correlated, provided with the correlation ID, which is typically the call ID. They can be correlated in one single entity. So for each call, you will be able to search what happened and see the correct and the exact SIP signal and SDP with the precise timestamps, so you can basically troubleshoot what's happening in your platform or identify a specific call that had a problem. And you can also have RTCP reports correlated to the same call, so you will have a decent idea of what was going on during that call, at least how provided by the applications that were producing data. Another interesting thing is that, so you know that there could be a logical call in your platform that it's in fact more than one SIP call. So what Homer can do is it can correlate these legs into one single logical call, and this is achieved by transporting the call ID from one leg to the other via a configurable custom SIP header that you can strip afterwards, of course. So this is how the search result appears typically, but we'll see it directly. So basically, you do a search and you have a bunch of results. These are they have the method, the accurate timestamp, and a few other information, in particular the call ID, which can help you to identify specifically the call you were interested in, and also the user agent that was producing the data. And this is how a typical, very simple call flow appears. So you can see that there are the main actor. In this case, the producer was the component in the middle. And if you click on a message, you can get all the details of that specific message, and including the SDP. We'll see it live. I think it's more interesting. Am I going so fast? Yes. And one thing that it's, I think, changes most of the interaction between the developers and the support teams typically is the collaboration tools that Homer makes available. So basically, once you have identified one call or one set of legs that you are interested in or that may have a problem, it's possible to share this information to your collaborators, and you can extract a pickup. So basically, Homer will build a pickup for you, or extract the picture with a call flow, or even just sharing a link, so you can send it via Slack or any other method. And granted, the receiver will have access to Homer. It will be able just to click on the link and see what you are seeing. So this is an extremely useful collaboration tool. Since Kamailio is the consumer of the data, and it's possible to customize its behavior. So there is a standard behavior that comes out of the box with Homer, but then you can customize it, and you can extract the statistics that you may need, since you have everything available. And you can do projects like Alfonso over there did a modification of Homer so that you could have a sort of reporting of error codes divided by country. So you could have a dashboard with the error codes divided by each country, so you could monitor specific destinations and identify spikes of errors and then go deeper and investigate, which was extremely useful. And of course, there are the statistics that are collected by Kamailio as long as the data comes in. Kamailio adds information on the statistics, and then based on specific thresholds that can be set, there are alarms that can be triggered, and for example, by sending an email to a specific collector. So for Homer, the Kamailio has a key role, which is the consumer of data, and so plays two parts: the producer of data and also the consumer. And for what concerns the consumer, the key point is that it must be a very fast consumer of data, but also writer of this information into the database, together with performing computation on statistical components and possibly even alarms, or do something very specific like getting the data and not just send it to MySQL, but also transfer it to an Elasticsearch system. This is, for example, I think it's the core configuration for a Kamailio inside Homer. So it just needs basically to know where to listen and what credentials to use to write into the database. And SIP capture is the module taking care of this. And what it's possible to do is, depending on the type of message on the method, for example, SIP capture will select a specific destination table or another. So you can have all the calls in one table, all the registrations in another, and all the other requests like options in a separate table, so that you can have a division, a separation of the data. This is an example of configuring SIP capture, which will inherit the MySQL credentials, and will be configured to use the head protocol, and then with some configuration items for managing the interaction with the database. This part, I think it's the part that makes some value in practice, because so when you're going to do your own deployment, you will face in large deployments you will have to deal with high loads. So granted that there can be high performances achieved by one single machine, the typical solution is the one that you probably apply also to your VoIP platform, which is dividing the traffic in multiple nodes. And this can happen at different levels. It could be multiple Homer nodes or multiple MySQL nodes, or anyway, the DB that you're using. And in other cases, you may have constraints like it happened to me, and you cannot make data flow from one data center to another. So you want to keep the data local in the data center. So the producer will produce in the local Homer, and then the GUI will be able to search the overall cluster of databases. Or other approaches at the lower level, which, for example, Paolo has been experimenting with, doing UDP level load balancing, so that the flow of UDP packets that carry HEP data are load balanced among a cluster of Homer machines, in fact, Kamailio machines, by doing load balancing at UDP level, so agnostic from what's actually transported. This is very simply the approach across data center. I think the main point here is that the API and the GUI can query more than one DB at the same time, and you will have the information aggregated all together, even if the data is separate. So it may be separate because you have a design constraint, or for perhaps even legal reasons, so you can keep the data locally, and then query it remotely and correlate it. Or you can do something like sharding by using the capability of Kamailio to use different MySQL servers depending on what type of traffic it's seeing. It could be made based on call ID or based on method of the request. And this is another technique to improve the overall capacity. For what concerns deployments, so there are various strategies to deploy. Typically, I find something different in every case that I work on, and so in general, there is a very nice bash script which works for. I think it's mainly to get you started, so you can have everything in one single box with a bash installer. And you don't need to do any particular customization. And this works fine, but doesn't necessarily cope with your current deployment system. So there is another method that is based on Docker, because the modularity of Homer works well with the way of separating the services into containers. And you can have, in fact, you could even have a Docker container with everything inside, and you have your image with Homer. You can carry it wherever you want and use it. Or there is the multi-container approach where each service has its own container. And we'll see it live. For who's more keen in using configuration management tools like Puppet, there is a module. And you can use it with a master, or you can use it even in standalone. You don't really need a master. And what I've been using it, I use it to install everything directly on the boxes, but also I use Puppet to manage the Docker containers. So it could be a way of integrating the two things. So if you have enough freedom to use containers, but still you have the constraint of using Puppet in your infrastructure, you can use the module to orchestrate the containers as well. And of course it opens the possibility to any other orchestration system like Kubernetes, whatever that can deploy the containers for you. Another typical case that I see is that where you want to deploy Homer, the DBA team typically says, well, this is going to be a DB, so we're going to take care of it. And this is perfectly fine, and it typically works. So you can delegate the management of the database to another team, and the interaction will be absolutely standard. There are no specific customizations. And you can configure Homer, in particular the container, in the container version you can configure it so that it won't even generate the MySQL container for you. So the bash installer, I think this may apply for a dangerous demo.
Yes.
Right now. So the minimalistic installation that I mentioned is with a bash installer. And so I'm going to, I have already everything installed in this machine, 413. So this is a Homer instance already running on a DigitalOcean box, and I placed some calls earlier on, and we can see the dashboard with some overall information. I made a search there using a call ID, which I'm going to do again. Perhaps not in the last 50 minutes. Oh, let's see everything. Okay, so this is a typical search result, and if you click on a call ID, you will have some information about that call. So I didn't bother here, but these IP addresses and ports here, of course you cannot do it for the clients, but for your own components, there is an alias table in the database by which you can associate IP addresses to ports. So when you see something like this, rather than seeing the IP address and port, you will see a service name, possibly with information on the data center. Let's see if so what I want to do is I want to kill this machine and reinstall it from scratch. This is why I think it may apply as dangerous demo. And I must admit I've done it already. So I'll rebuild it. So now it's going to destroy completely that machine and rebuild it. Rebuilding it so quickly, the IP address will be saved, so I won't have to change the configuration. But now, right now, you can see that there is no access anymore to that Homer, which is all gone together with the data. So now I'm going to use the bash installer to start from scratch. Okay.
That's the way to do it, isn't it?
Man in the middle.
Sorry. Extra security. Right, so is this sufficient in terms of sites even over there? Cool.
Yeah, even casting. Yeah.
So if I get the bash installer here, I'm just going to run it. It will just take some time to do the installation, and then I will provide the MySQL credentials. Okay, so it will take a couple of minutes. So meanwhile, what we can do is we can start talking about the Docker installation. So the nice thing about this is that it's based on Docker Compose. So there is one single file defining the services and the interaction that the services have one to another. So if we go to look into the Docker Compose file, you may probably see that there is the definition of the services. There's the web app, which contains the API and the GUI, a cron container for anything that is related to managing the data in the database, because of course you can imagine the huge amount of data that is created continuously in your platform. So all that needs to be rotated. It's configurable. It's typically rotated daily. Of course, it's configurable, and this container takes care of it. There's of course a Kamailio service, which is the collector of information. And of course, so what I did in other cases were having more than one container with Kamailio. So basically, that's another scaling strategy where if you are using Docker, you can have many containers, each one with a Kamailio, and then one separate MySQL DB, which may be running on Docker as well or not. But you basically use the modularity of Homer to adapt to your scaling issues. Okay, so let's generate the SSL certificates. Meanwhile, I'm going to connect to another machine where the Docker installation is being done. So we can start seeing the how it looks like. It looks like with Docker. Okay, so with a Docker PS, there are no running containers, but because they just been okay, there are no containers at all. Fine. I'll have to rebuild the containers, but it's part of the workshop anyway. Okay, so being managed by Compose, we can just run everything with Docker Compose up -d, then we'll have the containers running, so a Kamailio, a web app, a cron, and MySQL. Docker Compose will generate a dedicated network for it as well, so that the containers can address each other by using the name rather than you needing to know the IP address. And for example, if you're going to see the Kamailio, some internals about the Kamailio container, we can see that it's listening on UDP 1960, because this is where help will be received, and then it's linked with the MySQL container. This is pretty straightforward. Okay, so credentials for the Bash installer. Hopefully. Oopsie. This is why I said it was a dangerous pen.
Just a practice run, clearly. The real thing. Practicing for your crash and burn prize.
Yeah. Okay, something was clearly wrong here. Okay. I don't know, I may have lost connectivity in the middle, but I don't think so.
Yeah, the network's not good at the moment here.
No, I don't think it's the network. I'll
It isn't, clearly not.
well, I'll focus on the other one then, for now. So let's try to use the container-based version. Right, with the default credentials here. So this is the one running on containers. And this is a little detail on how to configure the container version with without also involving a MySQL container. Just provide user remote MySQL true into the Homer end, which is the Docker Compose environment file. We saw the containers in action. The Puppet module, I won't show it, but so it runs on Ubuntu and CentOS as well. There are small changes in terms of PHP libraries. And there are various parameters, but the main one, this is an example of the minimum information that you can provide to your Puppet agent or Puppet master. You basically define a user ID and password for, well, even just the host and the password for the Puppet module, and it will install everything for you. The advantage of this is that it provides support for Ubuntu as well, and it's very easy to customize and maybe reused quite easily in your platform if you're already using Puppet. Okay, now before this, I wanted to show you Kamailio live as producer with a very simple configuration. So we'll go into this machine. Okay, where Kamailio is running. But since I'm going to use a different Homer host in respect to what I planned, I'm going to edit Kamailio's configuration. So in this case, it's the zip trace module that is the main element, and I'm going to, into the duplicate URI, I'm going to set the IP address of the Docker-based Homer. Few configuration here. We're just telling zip trace not to trace on the database because it was initially designed for that. Use hep instead, and we set a flag so that we can make a correlation between a transaction and the responses to the same transaction. So in this case, you see it's very a minimal installation. We just trace everything. We send everything to Homer, and just for the invite we just apply a forward free. But I need to restart. Restart it. Like this, and then perhaps can grab. So I'm going to send an invite to this machine. Which is 196. This one. So very simple invite here. So I got the forbidden directly from Kamailio, and this is what happened basically. So there was an invite coming in to port 5060, and as soon as it came in, it was put inside a hep version 3 packet and sent to Homer. You can see the very first part of the trace is the binary headers that the hep packet is carrying, which are then used by Homer to fill the information to the database. So we can see the forbidden has been sent as well, and the ACK as well. So in Homer, in the last 10 minutes, hopefully, a typical problem with different time zones in machines. So we can see basically the code flow with what we just sent to that Kamailio machine. So this is SIP, and then we can go and see exactly the message, and it contains the full UDP. Sometimes these invites with SDP may become very large. The default limit is 1,500K, but it can be changed. It can be increased in the rotation ini configuration of the database. In this case, we don't have any quality of service report, but we are going to do another dangerous demo with FreeSwitch in this case. Just before that, so with Kamailio 5 there were a few improvements. One was a full HEP version 3 support, which means that the timestamps are more accurate, and it is in fact the standard for now. And there was, in fact, Kamailio added a very useful command to the SIP trace module, so that you can send directly log lines from Kamailio to Homer without any external application. So this is an example of something that we saw live already. So FreeSwitch as producer, as mentioned, support for Homer comes for free. It's just a configuration item in Sophia. And the tricky part with FreeSwitch is that in most of the cases you'll be probably using it as a back-to-back user agent with two different call IDs for A lag and B lag. So granted, FreeSwitch can take the call ID from A lag and put it inside a custom SIP header for B lag, then it will be available for Homer and there will be the correlation. So we'll see one single call flow. So I have a FreeSwitch machine somewhere here. Which I think is already okay, but I need to change the configuration because I changed the reference for Homer. So again, this is generic Sophia configuration, but it's more flexible than this. In particular, you can define your configuration per profile rather than globally for everything involved with Sophia. And also you can switch on and off Homer for FreeSwitch on selected profiles. So for example, it happened to me that Kamailio was producing data to Homer but sending traffic to FreeSwitch. So the A lag, the incoming lag to FreeSwitch was already known by Homer because it was produced by Kamailio, and I just wanted the B lag, the outgoing lag from FreeSwitch to be visible, so I switched off the capture in the internal profile and on in the external profile. The IP address of Homer is this one. Let's put it here, and then we go to the FreeSwitch CLI, and we reload Sophia. And then I will connect to this FreeSwitch and send some traffic there. Let's see if we can see it live as well. 5060 or 46. Okay, so we see the buy. So in this case as well, FreeSwitch just with a little configuration is sending data to Homer. Let's see what's visible here. Okay, and we see also the code that ended up into FreeSwitch. In fact, this is slightly more interesting code flow. And one information that I think is useful here is that we can see the user agent. So it's easy to identify which component was producing something. It may be useful also if you are debugging specific clients or to identify specific FreeSwitch versions, for example. So now, as mentioned initially, we want more than just SIP signaling from FreeSwitch. So I'm going to also send some non-SIP events that will be correlated to the same code. To do this, I'm going to use HelpPipe, which is a Node.js application. It's very simple, but it's also flexible because it has a few different modules, and each one covering a specific need. So you can see here, for example, the ESL client is a module that connects to FreeSwitch event socket, while the head client is the one responsible for communicating with Homer, and there is also Janus client, which is delegated to connect into Janus, get events, and again sends them to Homer. For the sake of this workshop, we'll see a simple configuration, which is just this one. The app config, of course, means indicates where Homer will be found. And again, I need to change this to adapt to the current Homer machine. Like this, and then the second part is the ESL configuration. So the event socket exposed by FreeSwitch, and which needs specific configuration to be able to be used. So HelpPipe will need to have the right password, but also potentially you can set specific ACLs so that you can limit access to the ESL to local applications, like in this case. So then it's just a matter of running HelpPipe. So in this case, HelpPipe is connected to FreeSwitch event socket, and it has subscribed to a few types of events. Let me show you which ones. So there are 3 types of events. So call generically, so it's everything that is happening inside a call, but also RTCP. So every 4 or 5 seconds, FreeSwitch may exchange RTCP reports, and these generate events that are visible to subscribed clients, like in this case HelpPipe. So in this case we have enabled everything. So call events is basically SIP. RTCP is RTCP reports. QoS is end of the call reports, which may happen in some cases with a summary, for example, of the packet loss or even a MOS score. So in this case, we have enabled everything. We're going to launch the application and then place again that call. So you can see here that so we can switch it off. You can see an example here where an event like the hang up event that the event socket has provided to HelpPipe has been packetized into a HEP packet and sent to home. So So this is a hang up event, for example, which I think is interesting because then you can see not just what SIP was flowing between the entities, but also what was the perception of free switch for that call and what was the direction of the hang up. And another interesting event is this one, which is a summary of the call stats, QoS stats of that specific call with a correlation ID. And this correlation ID is basically the call ID that Linkphone used to place the call. So if everything was fine, going into Homer again, we should see now an additional call, which is probably this one, 041. So in this case, we still see the SIP signaling, but also we have the logs of the entire call as provided by FreeSwitch, which can prove extremely useful while debugging, and also sort of quality of service report. In this case, we had a sudden rejection of the call because of a problem, but anyway, you can see that you may have seen a summary of the packets received or lost, and even sort of most computations. As mentioned before, so the export thing is the most useful. So everything that is SIP signaling can be exported into a pickup file, so that you can then share it with somebody. And this is, for example, the extracted SIP signaling directly for Homer. You may imagine how useful it is to just send this rather than other information, or having the need to do live capturing rather than being able to look in the past. So I think this is the main selling point. Talking of Wireshark, so we developed a dissector so that when you have HEP traffic flowing in your network, you can also trace it and check if everything is fine. And this is also useful to learn how HEP works. In this case, this is a HEP packet carrying SIP. You can see the information that it's carried, source and destination IP addresses, an accurate timestamp, and possibly even an authentication key, because you can work at this level by limiting who can produce the data to your machine. And of course a correlation ID, which will be used afterwards to do the correlation with other type of events. And for free, you get also all the actual SIP signaling, SIP message, as it was seen directly by Wireshark. So you see everything. And an example of HEP carrying logs. What changes is the type, the protocol type, and of course the payload, rather than carrying a SIP message, carries logs. And another example of payload, in this case it's an RTCP report as seen by Homer and correlated to the same call. So I mean, this shouldn't be needed in normal situations, but if you are curious about what you are observing in Homer in respect to what you see on the network, it's very useful. And also if you want to get into development and extend any functionality, may be an interesting, useful development tool. You can export of course you can export a picture, the call flow, probably go to another screen, but okay, it's a preview playing with me. But there is a picture with the call flow. And you can also get a link. In this case, it's not configured, but you can copy the link address and then send it over email or Slack. So these, I won't show CaptAgent, but you may imagine a similar approach with CaptAgent, where instead of configuring your application, you install and run CaptAgent on the machine that you're interested in. And through configuration, there are several modules. You can isolate SIP or ISUP or RTP reports, and can also apply sharding techniques with CaptAgent by sending some type of traffic to one Homer instance or another one. So I think I managed to go through everything that I wanted, and I'd like to leave some time for questions. But so in terms of conclusions, I think you'll be interested in the future of Homer. In this presentation that are linked here by Lorenzo, I think it's very interesting because it's basically moving from a SIP-centric approach to a more event-agnostic approach, where basically you can send every type of event, and the new Homer, which will be called HAPIC, will be able to do a correlation between these events and also graph the events, trying to get the relationship between the producer and the consumer of the data. So I suggest you see this presentation. Also, PASTAC will be a generic purpose Node.js application which will replace HAPI. It has a similar approach, but it's different in the internals, and it will be developed in the future. And on Wednesday, there will be Alexander presenting his distributed system for blacklisting and fraud prevention, which I suggest you will attend. And I think, well, thanks, first and foremost, Lorenzo and Alexander, but also Federico, and Doug Smith, who's the main author of the container part of the multi-container approach. And that's it. So any questions?
Yeah, okay.
I can guess at least one.
Can you please point more on QoS and how it's related to actual call quality that is known to MOS? And is there any, for example, on the vanilla Homer, make it like if QoS and if the call quality on the certain, let's say, destination goes bad, to raise some kind of event, to receive emails and something like this?
Okay, so the question was about the relationship with QoS and whether there is any type of alarm that can be set when there is a specific quality of service condition, like, for example, a bad MOS. So without interacting directly with RTP, what Homer does is it gets events related to RTCP reports and end-of-call reports from the various components. So for example, TreeSwitch can forward all the RTCP reports, and then Homer will generate the statistics for you, and you will be able to see them. But also at the end of the call, for example, in particular if you use some codecs like Opus, you have a summary at the end of the call in terms of packet exchanged, and also when FEC was involved, for example, and an overall MOS estimation. But all this is done not looking into the RTP by getting the information that the application is seeing. In this case, for example, FreeSwitch. There is a sort of extension of CaptAgent, which is called RTP agent. In this case, this is a commercial solution that Alexander developed, and this is able to see the RTP as well. And it's able to make computations on the RTP in terms of packet loss, doing the correlation live. And then I'm pretty sure, but you will need to ask Alexander, I'm pretty sure you can set up thresholds to send alarms. And all this happens without actually storing the RTP for security or low reasons, but by looking at the RTP live. So RTP agent probably is something you want to take a look at.
Okay, other questions? Hi.
I'm quite interested on the API part. I, for instance, want to know if we can get all the statistic information you show on the main web interface to be used like inside my own interface. Is that possible?
Yes, I think it's possible. Yeah. The API is very simple, and also it's. I wonder if I can see it live. So, for example, say. Just give me a second. I'll try to see it live. It's a very simple API, and I'm pretty sure you can see that because the GUI is just using that, so it's not accessing the data directly. So there are these widgets that you can plug and play into the dashboard, and each one has its own set of queries. So by looking at that,
for instance, if I want to render my SIP diagram, I could do it by asking the API, right? And all the other widgets that you are using right now.
Yes, definitely. Yeah, there's nothing that the GUI is doing without passing through the APIs.
Okay.
So one easy thing would be, doing what I'm doing and reverse engineering the API by grabbing it. And you can see, for example, is it the response? Let's see if I can get the request. There is a lot of information exchanged, but because I think
just install Homer to grab Homer.
Yeah.
One other question regarding Elasticsearch and everything. That's the new part coming, right?
Well, in fact, that's already available. We can offline. I can provide you with some information. It's already available. It's basically a modification that you can do in the Kamailio that is installed inside Homer. And basically what you do is you will have your Elasticsearch endpoint. You have to get the data and perform an HTTP request possibly to Elasticsearch. And so to do this, the Federico's module, which is the asynchronous HTTP client, can be used so that basically you can place several HTTP requests in parallel without blocking the workers, and you can continue processing the other traffic.
Okay, thank you.
Okay, last question or?
I have a question about the quality of service. Is it available here? Is it available to have that information for peer-to-peer calls? I mean, we're not having RTP engine. How do you get those information?
Information of peer-to-peer
quality of service.
Well, that information, as I described, comes from the components that are in the middle. So you have typically two choices. Either you get that information from FreeSwitch or, for example, Asterisk, Janus as well. Or you can put capt agent somewhere, capt agent and RTP agent somewhere that sees the traffic. If you say it's peer-to-peer, but I imagine there will be the traffic visible on some machine, which could be mirrored, for example, then you can use capt agent and RTP agent to get the same information.
Okay, thanks.
I know that in the past, I haven't checked it now, but some phones they send a buy with the header, and I know that they process that offline, but it's not real-time feedback on the quality at the end of the call. There is a special header with a summary of communication, like how many packets lost and so on. I think Cisco does it and so on. And then could be properly peer-to-peer communication. But again, you get these reports at the end of the call through the signaling. Okay, thank you, Giacomo. One important note before the break and other things. One of the networks apparently reached the capacity or something happened, but there is a second one which is called FAG guests, where after you need a username and password on a web page when first try to access the internet. You have the flyer in the back. So if the internet is not working for you on the initial network, there is a second one. You have to take flyers for username and password from the registration desk or in the back. So there are two networks. One of them should get you in by the capacity of this room, sorry. And before going, so we have some drinks and eventually some sandwiches left for today. Tomorrow we'll have catering with buffet. As Randy said that he wants to give away a nice t-shirt, maybe he can show it first, or you don't want to show it? Oh yeah, I'm going to show it. Maybe some people will get scared and they don't want it.
I'm going to try to say this if English isn't your language. This is a beautiful t-shirt. I love these, and let me tell you something. Yes, so I don't have three hands. People come up to you on the street, okay? But if you are not a medium size, if you can't wear medium, or if for some reason this isn't your thing, you maybe have a nephew, a daughter, son who would like this. I only have 10 cards, so you have 10 chances. Now you have to raise your hand and I'll come around and give you a card and we'll see who wins. Good, we got enough people here? Yeah.
Lots of people want that.
I think Sandro will bring another one or two tomorrow.
Yeah,
but anyhow, you know, the Kamailio one, it's nice, you know. With ours, we can go on date with that one.
Smart.
You're not doing anything. A drill. I mean, listen.
Randy, try also the other side of the room.
Oh. Wait, I have to go to the other side.
I had to turn on my own.
Also on the back there are some bags if you want with Kamailio logo, and tomorrow I know that some guys will bring a bit more t-shirts and other goodies, but they will announce it in the morning.
They know to. They put on that. I've got another turn on the
Look at the back of the card.
Maxine.
You'll see that there's a bunch of...
Randy?
You can stop it now. Those of you who have 10 lucky people, look at the card. There's a bunch of ticks on one edge, and on the other edge, the winner has one tick. Tick meaning a little tiny line. If you don't know, you'll have to bring it up. If you haven't found it, you'll have to come up here and...
Does this include erasing too?
All right, wait a minute. That's not it. Keep the cards, folks.
Sounds like a dangerous game.
No good. Nope. Who else had that card? Nope. Wait a minute. Okay. Wait. See. Nope. Well, this is hard. Who knew that climate control was so hard? You have it. That's it. That's the tick. Okay. You got it. Congratulations.
Sherman and myself today.
Hey, I'm trying to. Wait, the line. Thank you, Mario. How did it have to be the last person? 10. I went through all 10.
Wow. Hoffa.
Murphy's Law. What happened? So James.
Yes. You need to apply things, do you? Okay, well just go.
Lorenzo, that's awesome.
That's my go-to wallpaper for everything.
Yeah. Well, I guess we're maybe charging then, huh? Are you guys got your...
Yeah, I've got you.
Done?
Yeah, I'm on.
How's it going? I was hoping this would get forever. I can claim they were mine.
I'm sorry. We'll be around. I shall see you later. You coming back to the hotel, or you?
I don't know yet.
Okay, well, I'll find out later.
Yeah, we can communicate on a good day.
so political, magical enough after a good presentation. That calls.
HDMI in. Oh.
Piece of somehow. In fact, I'm going to the literal history of saying this is how we did it so far, and all the graphics using the game. You need to drop the game a bit, basically.
Well, I've never served
I'll be right back. I'll get my pot.
So I just I often forget about this. It was the phrase last year that just keep silent the whole time. That should be fine. In case I had any issue with it, I can just
Okay, I'll get the guys in now.
Are you recording audio from this, or do you have an external microphone?
No, from this.
So we need to kind of play it.
Yeah, I know. That's what they usually do during the talk.
This is a nice setup.
Oh, thank you.
How long have you been working with the project?
Which one?
Kamailio and everything. Long time, right?
Since 2003 at least.
The same, yeah, so same as me.
Yeah, if you look at the Node helper.
So Maxine, what's this box? HDMI in. Do you take video in here? It's a frame grabber?
Yeah.
Wow, how much is it?
680 or something. I don't know.
Euro? Dollars.
Okay, let's prepare for the next session.
Impressive.
Next group of sessions, I see Sherman putting a lot of stuff here, so should be quite interesting before going out and allow you a bit of time to visit Berlin. So we'll have Lorenzo, then we'll have Sherman, and I'll close the sessions today. Lorenzo is already scaling us with some XML. I thought everything is JSON these days.
Configuration menu.
Okay, so we're ready to start. Lorenzo from Janus, I don't know how it's pronounced, Meetecho. The company, but the project, open source, Janus. If you don't know exactly, because the talk is going to be slightly different now, we have a recording from the last year where Lorenzo was also present and introducing that project. A very good WebRTC gateway, so you can connect the legacy SIP, PSTN, whatever, with the future world of web and RTC. Now he's getting more into the practical talk with load testing of SIP and WebRTC infrastructure. These guys are doing amazing work with a lot of video stuff. So if you're familiar with ITF, there are those streaming all these sessions from the ITF events. So you can pick his brain on a lot of stuff related to real-time communication. Lorenzo, thanks again for coming. Now, time for you.
Thanks, Daniel, for the introduction, and thanks for being here. I didn't expect the workshop to be so crowded, so I hope I'll be up to the task today. So, as Daniel was saying, this talk will not involve Janus, even though I'll probably use the Janus here and there just for the sake of some steps that I'll describe, just because I have it installed, it's easier for me to do, but the steps, the things that I'll explain here should be easy enough to apply to any kind of SIP and WebRTC-based infrastructure, and I'll also try to explain why that is. And in particular, the presentation I'm going to make today is also not meant to be a complete, let's say, overview on everything that can be done in this specific field. It mostly focuses on our own experience as a team on this kind of tasks, because of course we also have had the need of doing something like this, whether it was on plain SIP in the past or WebRTC right now. And so I'm going to share our experience on this and the way we tackle these things. So in case you feel there's anything missing and so on, please feel free to tell me during the presentation at the end and so on, so that we can make this as much a part of the conversation as the content of the presentation itself. And so let's go with the presentation. I mean, this is just a brief agenda of what I'll go through. I'll start with a brief introduction about what you can do to stress SIP infrastructures right now, and this is one of the things you probably know much more about than me, so I'll go pretty fast on it, just to show you a couple of tools that you can use for the job and how they work so fast, and but more in particular to explain why this kind of approaches mostly don't work whenever you want to get to WebRTC in the future. So I try to explain why that is. So, and I also try to explain different ways you can try and cope with this in the WebRTC way. And as Daniel said, yeah, this is my second time in Kamailio, so you may remember me from last year. There is a recording of the presentation I made on Janus. I love this picture, so I put it everywhere I go. I hope you won't mind. And then just a couple of words on us. I'm one of the co-founders of Meetecho. So we were born as an academic spin-off a few years ago. So all the members of Meetecho are either PhD students or people who got their PhD degree with a professor who is Simon Pietro Romano. So at the time we worked a lot on research activities within the university, a lot of multimedia applications. Eventually we came up with something that we thought could be called a product, and so that's how Meetecho was born.
And since then, we basically try to widen the scope to real-time multimedia applications in general. So not just web conferencing as in the beginning, but pretty much everything that has video or audio or text or anything real-time going one way to the other. And of course, for this, WebRTC proved to be a great opportunity for us, which is also the framework in which Janus was born when we decided to start tackling this. And of course, we do all the kind of activities that you can expect from a small company like us. This is where we live and work, and actually I think this picture contains both the office and my home somewhere. I'm not sure where exactly. So I live around here, the office is around here, so a nice place to be if you want. And so, starting with the actual content of the presentation, of course, whenever we talk about load testing of SIP infrastructures, we actually don't mention a single thing. So it can actually mean different things. So in particular, we may be interested in how many SIP sessions, for instance, our service can handle, but this also doesn't tell us everything, because it may be in terms of how many calls per second, how many concurrent calls, is the quality good enough? When numbers increase, does that number change, of course, when media is involved? How can I involve media in the picture when doing load testing? And so when probably I will not have real media that is actually being originated, I have to simulate it somehow and things like this. And so, as you can expect, this is quite a complex task to take into account, considering, of course, that programmability and customizability are important requirements when you do something like this, because one thing is to just have a tool that just generates a lot of calls per second and stuff like this, but not all applications are the same. So the call flow may be different. So it may be different from a simple invite, 100OK, ACK, and buy after a while. You may involve different steps. There may be interaction with the user simulated via DJMF tones and stuff like this. Different applications have, of course, different scenarios that you have to tackle. You may also want to simulate and orchestrate different topologies and things like this. So all things that are to be taken into account. You may want to have custom headers, fields, and stuff like this that may need to be different in terms of different people accessing the service and not just the same user that you replicate 100 of times and stuff like this. So you get the point. And luckily enough, in the SIP world, there are several tools that can be actually used for the purpose. One of which, and the one that I'm going to talk a bit today, is CPP, which is probably the de facto standard when it comes to this. It's an open source component that allows you to design complex scenarios and then generate test campaigns for this, something that we used in the past as well. There's Seagull, which is also another popular open source multi-platform, in this case, traffic generator, and there are others, so you'll find many more if you look around. Most of them are also not open source, they may be proprietary, there may be people charging for the service, which is of course normal, but you get the picture. There are a lot of ways that you can do these kind of things. And as I was saying, we'll focus a bit on CPP, mostly because it's the one that we as a company were more familiar with. It's the tool that we used when we needed something like this in the past. And as I was saying, we think it's probably the de facto standard tool for generating SIP traffic, whether this involves media or not, because I chatted with many people in the past about this, and they almost always use this, and it looks like it's still being used quite a lot in the testing of SIP-based infrastructures. And in case you don't know how it works, it basically makes use of XML files to design the testing campaign. So as we'll see in a minute, because I'll show a simple snippet of how this works, you basically create an XML file with the expected scenario that you are trying to explain. So in terms of the sequence of messages, in terms of maybe custom fields that you may want to add, static or dynamic headers, stuff that may need to be dynamic in terms of what you pass when you execute it, and so on. And the interesting thing is that, of course, if you want to start quickly, there are these, CPP also comes from some precompiled scenarios. So if you just need a simple user agent client or a simple user agent server, there are ways to spawn them quite easily without you having to worry too much about designing an XML file yourself. But of course, if we want to do some more complex things and so on, being able to understand how these XML files work and being able to actually modify them somehow actually helps in making things more complicated than it is by default. And there are also options to customize the session, as I was saying, even in real time. So for instance, you started with let's say a rate of 50 calls per second or something like this. There are ways to increase this dynamically from the simple CPP console application so that you can actually change a bit the dynamics of the scenario that you are trying to reproduce. And this is an important aspect. This is not only related to signaling, because of course XML files are mostly focused on signaling itself, but you can also involve media in the process, which means that you can generate a zip code that actually starts exchanging RTP media with the service that you're trying to test, which means that you can have, in particular with respect to CPP, you can have a pickup file, so a file that you captured before with TCP dump, Wireshark, or whatever, available, and you may want to just replay the contents of this pre-captured file so that it is actually used as the RTP source for the call itself, which is actually kind of interesting because it allows you to actually do a call with media with basically really close to none overhead in terms of CPU consumption, because all the tool is doing is basically just accessing a pre-recorded file and then just shooting the RTP packet at the exact moment and so on, of course using the ports that were used for the negotiation and things like this. And when you actually start then CPP, it looks pretty much like this. So you have an overview of the scenario that you described in the XML file, and this simple sequence diagram which explains would differ, of course, depending on how you actually designed the XML file yourself. It gives you an overview of the current configuration of what has happened and so on. And of course, it also gives you an overview of whatever is happening at that specific moment. So how many messages of a specific step in the sequence diagram, the sequence steps that you described have been taken care of, what is going to change, and so on. And if we want to have a look at how the XML looks like, in principle, we can summarize it like this. So this is a simple example of how you can design a very simple user agent client with CPP. So as you can see, you have a scenario element that you can then just populate with the different steps that need to be part of the testing campaign. And so we may want to start with a simple, we start with a message. In this case, I'm just snipping it for visibility reasons, but I'll show you this, for example, later. We may start with an invite, and then we'll say that we are going to expect either a 100 and 180 or a 200 back. So we are okay in getting provisional responses and so on. At the end, we expect the 200 to actually reply to our own invite. After that, we plan to send an ACK, of course, and then we may pause for some time to say this call is going to last, let's say, 20, 30 seconds, depending on the scenario that you are going to exemplify. And after that, in this case, after 30 seconds, we are going to send a bye message, and we are going to expect a 200 back. So if when we do this campaign, everything works as expected, then the CPP tool will basically show us all the dynamics of the specific call scenario in the interface and so on. And if we explode that first part, so for instance the invite part, this is how we may actually design the complete message that we are going to send as part of this testing campaign. So in this case, you see there are a lot of parts that are actually dynamic. So the ones that you see in the square brackets are all parts that actually the CPP tool is going to inject dynamically for each call. And some of these may actually be driven by something that you provide yourself, either via command line or somewhere else. Others may actually be generated dynamically by the tool. So for instance, the call ID may be something that the tool may introduce dynamically to use a different one for each call and stuff like this. And in this case, you can see that in this example, I added a custom header that needs to be part of all the invites, because this may be part of the service that I'm testing. I'm passing, for instance, a custom subject and so on. I'm specifying in the SDP that I want to negotiate ALO, so all the parts that are related to the dynamic negotiation, of course, with the media port that is going to be dynamic, so to allow the CPP tool to negotiate stuff and handle RTP on its own. And that's pretty much it. So you'll see there are several other fields that you can configure, which is kind of cool. And of course, how does media get into this at this point? As you can expect, the ability to send or not send media is actually part of the XML scenario itself. So the XML scenario describes exactly what the CPP tool needs to do during all the code that we are going to replicate, which means that it makes sense to have an additional part in the XML file to address exactly this. And in fact, it's pretty straightforward. We typically just use this XML snippet that looks like this, where you point to the pickup file that you want to replicate, and you have to match it with a pause element that basically says pause for this amount of time, which is basically the length of the pickup file, which to make a simple example. So in this case, I'm introducing a simple auto pre-recorded RTP snippet that comes shipped with the CPP tools itself, which lasts about 8 seconds if you listen to it, which means that I can just inject these here, add a pause there, and so on. If I need more, I can generate my own traffic and stuff like this. And if we have a quick look at how a complete XML file looks like, this is the one that I'm going to use in a minute in a very simple demo that we can use to show how it works. And as you can see, this is exactly the same that I've just displayed in the slide. So you can see exactly the same custom header, some additional information, a custom subject, and so on. And this is the complete scenario. So again, I'm going to expect either an original response is fine, I'm not going to care much about it. The important thing is that I receive a 200, then I'll send an ACK back. Again, I'm providing the whole content of the ACK message that I'm going to send back. I'll pre-record some data for a little while, and then I'll send a by after a few seconds. So if we want to see how this all works, we can just, let's say, spawn an asterisk here just as the service that we want to stress in this case, and then I can just you can just generate the traffic using this CPP tool that we've seen so far. And so if we look at the CPP can just be launched via the command line. So I'm going to do exactly that, which is I'm going to use run as a sudo, because if you want to replay the RTP stream, you need to have access to some stuff that the normal user would not be able to do. And in general, I'm telling the CPP tool to use this XML file as a scenario that we for the stuff that we want to do. I'm saying that I'm going just to generate a couple of calls per second. There's going to be a limit of 100 concurrent calls at the same time, but in general, I want to test 300 calls for. In general, basically. And then I have some additional information like the duration of the call, some stuff related to the ports, and most importantly, the servers that I want to call. And in this case, I'm going to call the echo test extension on asterisk on the EP of my machine. So let's see if this works right now. So right now you can see that the tool has started generating the calls as I was saying. So you can see that about 2 calls per second are being generated, and of course some are still in the pause part, and so you'll see that in a minute we'll start seeing some buys originated, because I have a couple of replays that to make the call basically last about 15 seconds, and after that, as soon as the first call ends, you can see that some of the calls are being hanged up as part of this, which is all reflected, of course, in the asterisk console, which shows you that I'm actually handling all these calls and exchanging media with them as a consequence of that. And as I was saying, I can also increase a bit the rate to have, let's say, more calls being sent at the same time and stuff like this. So in this case, I'm sending 4 calls a second instead of 2, and so on, all things that I can change dynamically, basically. So as you see, nothing complicated in principle, but this kind of works. So coming back to the slides, of course, as you can understand, CPP in principle is very powerful, but designing those XML files can be a problem, because it can be problematic to design scenarios that are complex enough by hand and so on. And fortunately, there are a couple of tools that will not go through, but I'll just summarize here for your convenience. For instance, there is a tool called CPP Cap by Mojolingo that allows you to basically design these diagrams, these campaigns in a more user-friendly way, and that gets translated in turn in the XML files that you end up using with CPP eventually. But it makes things much easier, of course. And of course, CPP Cap and other tools as well also provide some web front ends to make things easier, also in terms of how to handle the amount of information that you get out of all these testing campaigns. And for instance, the Mojolingo authors have a tool that allows you to basically summarize all the results of a testing campaign, so that you can then evaluate them for your own needs and stuff like this. So all of this introduction For what? To basically say that most of the stuff that I've talked so far does not apply that easily to WebRTC, and we'll see why in a second. So you may have seen this very ugly slide before, because this is another of the slides that I always use, even though I should probably replace it because it's really ugly. But in principle, it makes you understand that in principle, WebRTC kind of looks like SIP. So the WebRTC typical architecture looks like a bit the SIP trapezoid, if you like, where you have two people exchanging information in terms of signaling and negotiation with, in this case, a web server, and then eventually exchange media peer-to-peer. The problem is that the signaling that you see over there is not, say, mandatory. So there is no way to actually know in advance which signaling is going to be used with some specific WebRTC services or not. And so you cannot assume that the signaling there will be SIP, for instance. Actually, most of the services, it will be something else, which means that if you want this WebRTC user to talk with the SIP endpoint on the other end, who doesn't talk all the stuff that the WebRTC standards introduced, you'll have to put something in the middle to take care of that. So something that either takes care of the signaling, and at the very least, for instance, it needs to expose a WebSocket interface if you're still using SIP, for instance. So if you're still using, for instance, with Kamailio, you can use SIP over WebSockets. In that case, you have to make sure that the SIP over WebSockets, for instance, gets to a SIP that is either over UDP or TCP or something like this on the other end, or you have to take care of a whole signaling translation mechanism in principle, and even possibly SDP adaptation, because again, the SDP is what will end up in the establishment of a media connection, and the SDP WebRTC users will use is actually going to have a lot of information that regular SIP users will not be able to use at all. So stuff that may be related to ICE, DTLS, SRTP, and stuff like this. And this is because, as I was mentioning, WebRTC added a lot of stuff to the plain SIP-based infrastructure. So again, I was saying that the signaling is not standardized, even though there is a, let's say, a state machine that needs to be followed in order to keep things working on the WebRTC. And SDP is still used, even though it's something like SIP SDP on steroids, so we need to take care of that. And then a lot of things that you need to implement that may not be part of a SIP infrastructure, something that typically drives some people crazy. But likely for you, there's people who have taken care of this on your behalf. The problem with load testing is that, first of all, simulating users is not as trivial as we've seen with CPP, for instance. And that's because a WebRTC client is typically, even if we just assume a web page or something, they are not just simply web users, because again, one part is of course the web interface, so interacting HTML5, JavaScript and things like this, but then there is also a whole lot of stuff that you cannot do with simple web replays and things like this. So all the WebRTC part is really dynamic and is not, strictly speaking, a web application if you think about it. And at the same time, they are not regular SIP clients either, for the reasons that we've seen before. So there is a whole lot of protocols, a whole additional lot of protocols that you need to take into account, which is actually kind of problematic to simulate and to handle. Which means that CPP, for instance, would not help you simulate and stress a WebRTC infrastructure, because although it might work with the signaling part somehow, so if you take care, for instance, of proxying the WebSocket stuff and things like this your own way, but definitely you cannot use pickup files to just replay media as you did with regular SIP infrastructure. And for a simple reason, I mean, WebRTC is very dynamic in the terms of how you exchange, how you establish a media connection, which does not couple well with simple replaying of media, because you need to take care of all the ICE process in order to establish a working communication between two endpoints, and that's very dynamic, as you can expect. Something that you cannot just replay, because there will also to be authentication involved and so on. Even if you coupled with the coped with the ICE stuff, then you need to take care of DTLS, which again is something that you establish on the fly, not something that you can replay. And of course, because replays is something one of the things that DTLS and SRTP are trying to prevent in the first place. And in principle, as you can imagine, WebRTC is simply too dynamic to just replay traffic and so on, and so CPP is not a good option in this case. And while there are some tools that allow you to generate a lot of HTTPS or WebSockets traffic, like JMeter, Siege, HTTPerf, and things like this, as we were saying, they are not fit for WebRTC because they only would handle the HTTP part. So you can download the same page 10,000 times, but it really doesn't suit the purpose, because what you want to do is not how many people can actually just open the page and display the HTML content, but how many of those users will be able to establish a working WebRTC connectivity with it, something that these tools don't provide. And while you think that maybe Phantom.js could help you with that because it allows you to simulate all the, and automate, most importantly, all the JavaScript parts, that's not enough either, because so far Phantom.js doesn't support WebRTC yet. So it does allow you to do some WebRTC, some JavaScript dynamic stuff, but it doesn't allow you to create WebRTC peer connection and things like this. So you may be wondering at this point, are we completely lost, or is there something that we can do? And of course, I'm just halfway through my presentation, so I hope I left some solutions for you. One of those being what we, in Napoli, we might call the pane puparoli way. Pane puparoli means basically just a slice of bread with some pepper on it, which means, and in Napolitan it means something that is really trivial and easy, but at least gives you a bit of flavor, basically. So the easiest way that you can do is to basically just open multiple tabs, because while, as we were saying, WebRTC users are not regular CPU users, on another aspect they are actually more fit than CPU users in order to do some testing and so on, because they are basically web applications, and web applications are scriptable. You can do a lot more things if you mess with JavaScript and so on, which is actually kind of a nice thing. Especially because it's much easier in this case to open a lot of pages exposing your own soft phone interface than opening, let's say, a ton of soft phones at the same time, which is actually kind of cool. And that's possible, of course, because JavaScript allows you for doing something like this. Of course, this is just the pane puparoli way, meaning that it's the really easy and quick way to get something working, so to generate, let's say, 20, 30 calls at the same time and see how it works. But of course, there are severe limitations, because let's say, there may be a limit on how many tabs you open yourself, how many browsers you can open on a single machine before it melts down. There may be local resources that are exhausted, or even just, if you think about it, the browser connection limits may be exhausted, because, for instance, in all the browsers, there's a limit on how many HTTP connections you can send towards the same web server. So if you're using, for instance, long polling in your application, and then you open 10, 20 tabs at the same time, those long polls will keep the HTTP connections busy, the regular request will not be able to get through to the same web server, the application will not work, basically. So all things that need to be taken into account. And of course, for resources, there may be some things that you can do to prevent the machine from overusing your resources. So for instance, you may use fake devices rather than accessing the actual microphone, webcam, or things like this. And other things that you can do to increase the behavior and so on. You can get friends to help and so on, but how many people can you involve into a test like this? For instance, it's 5 of us in the Miteco office. I may involve all of them for a test that we can do, but at this point, all of our laptops are busy just doing that. There's nothing else we can do. There is to be some way that we can use the same approach in a more efficient way, let's say, rather than just let's say, do this thing and then do something else. And so, as you may have understood, this is actually very silly and very naive, but it's actually a good starting point to do something more efficient, as we'll see, especially if you find a way to automate and robotize all of this, which is exactly what I'm going to talk right now, which is the so-called Selenium HQ, which is a tool that basically allows you to do remote browser automation, which means what? It basically means that, considering that web applications are scriptable by definition, and most importantly, they can also collect statistics, which is also important, for instance, for the question that one person in the audience made before to Giacomo during his presentation. Even if you have a peer-to-peer call, you can still collect statistics on both sides of the communication using JavaScript, for instance, and pipe this information towards a component that can digest and use them. So, for instance, Hover in this case, which makes these endpoints, so even this software, if you are just doing a SIG-based application over WebRTC, much more powerful than a simple and configurable than a simple SIG software, because you can do pretty much everything that you need in order to automate some of the aspects and do some cool things. And basically, Selenium allows you to spawn remotely controlled browser instances and then open a specific web page and then drive whatever needs to happen to simulate JavaScript communication, dynamic user input, and stuff like this. which is kind of interesting because any of these scenarios, so any of these controllable browser instances that you can do, can actually be implemented in different programming languages. So Selenium provides binding for a few of them. In a minute I'm going to show you how I can actually do something like this with JavaScript, which is kind of cool. Of course, this needs a hook with the native specific browsers, and Selenium provides web drivers for different browsers. So you'll have a driver for Firefox, a driver for Chrome, and things like this. I was mentioning fake devices before, because especially if you're going to do this browser automation not on your own machine, but on a server somewhere, there may be no webcam to actually access, or you may not want it to have access to any webcam and so on. Which means that fake devices can greatly help you with this task. And most importantly, considering that, in case you don't know, WebRTC also asks you for the permission anytime you access a specific device, a microphone, a webcam, and so on. If we want to avoid that step, because it basically hinders our ability to automate some of these things, there are also flags that you can set in these browsers to actually prevent that part. So you assume that the permission has been accepted and you move on, so without having to worry about that step. There are also tricks that allow you to start these browsers in a headless way. So, for instance, without actually presenting a browser instance on the machine that you are going to simulate. In this case, I'm not going to use them, so in the example that I'll show you in a minute, I'll show you how I can spawn a browser and do something that I want so that you'll be able to see exactly what happens. But of course, this takes resources because it uses the graphic card and so on. Some servers may actually not even have a graphic card, they may be completely headless. So you may want to use stuff like the virtual frame buffers and so on to actually get rid of that part, which would make also the simulation much easier to handle. And in the future, maybe, who knows, the headless Chromium stuff that has been added recently may also help in that sense. And this is actually a quite cool and powerful feature because there's a popular company that does RTC-based testing that is called TestRTC. And of course, they do a lot of stuff, additional stuff, but Selenium is actually part of the foundation of what they do. So just to make you understand, it's actually a quite powerful thing. So just to give you an idea of how you can actually design a scenario to do something, I'm showing you here a simple example of a, as you can see, very short Node.js application that shows you how you can open a web page, decide how the simulated user must behave, and then do something. So just to give you an idea, I'm going to use the JavaScript test demo. So this is just, I'm going to show you first the demo used in an interactive way. So I'm going to insert some data into it and so on. And then I'll show you how I can automate all these steps in a simple scripting language, which in this case is JavaScript, to basically simulate the behavior in a programmatic way. So let me just start Janus in a second. It should be already up and running. So this is the SIP gateway demo page. Let me start asterisk again, because that's what I'm going to talk to. So as the first thing, whenever you load the page, you have to press the start button. So this is something that I'm going to do manually. Then, as you would expect of any kind of demo, so also JS SIP demos would work pretty much the same way. For instance, you have to insert some information. I'm going to insert this JavaScript user, which is one of the registered users on this machine. Let me check the IP of the machine here just a second. If I can find them out of it. This is my identity right now in the platform. I'm going to use my password, and I have to choose which registration approach I'm going to use. So this is something else that needs to be part, of course, of the user interaction. Just for the sake of simplicity, I'm going to use the plain secret. Another pop-up appears. I need to take this into account if I want to automate this process. Then I just register. I'm ready to do a call. Now I can just call, for instance, the echo test as I was doing before with CPP. Call, allow, and you can see that I'm just now in the call and so on. After some time, I may decide to just hang up the call, which means pressing that specific button and this scenario ends. So, as you can see, there are some things that I need to do in order to simulate all of this, which is exactly what this scenario here does. So the first thing it says, open the Selenium web driver, do it for Chrome, use a fake device, so I'm not going to use a real webcam, use a real microphone and so on. Don't ask me for any permission, that's that flag over there. Then I'm going to say, open this web page over here, which is the zip test demo, and then do a little steps in sequence. So press the start button, insert this value in the username part, insert this value in the password part, click that part which was the drop-down menu to choose which kind of secret you want, make sure that you address that pop-up that I was going to show, press register, wait a bit, insert this URL in the field that I'm going to call, press click, wait 10 seconds, and then press that same button again to hang up the call. So, as you see, really easy, but also something that you need to take into account depending on how your application works. And now we are going to see it running to see if it's actually working exactly as we expected. And in particular, I'm going to use, let me see if I can show you this in a more easy way. I'm going to use a slightly modified version of this with some additional sleep in it, because normally all those tests would be very fast because it would be all automated. I'm going to wait, let's say, a second anytime I do something so that you can see that it's actually doing something in an automated way without having me doing anything on its behalf. And so I can just do node test1.js, and we should see, oops, sorry, I forgot to start the Selenium driver. Just a second. Actually, it's another issue. Just give me a second. Okay. This cool stuff that I actually forgot.
It's getting a bit dangerous, isn't it?
Yeah, it's very dangerous. And it's actually kind of a spoiler alert. Part of this will also be in the dangerous demo that I'm not going to say more. So I better hope it works, because otherwise I'd like to go home tomorrow.
Lorenzo, I have a bunch of double quotes if you're missing more.
No, I'm okay. So I should be done. Okay, I'll have to probably fix another one as well, but that should be it. So I can start it. We should see a browser that has appeared, of course, in the wrong window, which is this one. It has already started doing some things on its own, so writing the name, pressing the button. Of course, it's called the DNS error for some reason, which is probably related to the address I used. Again to see if it was temporary. I mean, it's not working right now, but as you can expect, in general, this would eventually result in a zip code. So in this case, it's probably related to some aspect related to the network here, but you get the idea. If that register had succeeded, I would have ended up into the call part that would have resulted into the button to call, and eventually the call generated via the WebRTC stack of the browser. So that's basically how it would have worked. Maybe later I can try and figure out something. Yeah, it shouldn't be the issue though. So just let me modify the demo in a second to see if using a different one works. So just let's put the address over here. So also the right address here. So again, wrong. Wrong monitor. Okay, it did work. So I am an idiot. So okay. But then this, you can see that I wasn't lying to you. Now it really did work. You can probably hear the stuff, the demo working, and this was only lasting 10 seconds. So the echo test was playing something after 10 seconds, getting up, and like this. Of course, this is only interesting if we can automate it somehow. And so let's see, just for fun, if we can just do it. First of all, let me check if I have the same double quote kind of thing here. And probably, no, the address shouldn't be an issue because it's dynamic in this part of the demo, but so this is a slightly more complicated version of exactly the same thing, because as you can see, the way that we generate the data to interact with the driver is exactly the same. What we are doing is just, let's say, spicing it a bit. So I added some command line arguments by which I can specify a rate, a call limit, a max code. So pretty much the same thing that we did with CPP in a very basic way. I have some defaults in here just to do some kind of cool things. But the idea here is to use this Node.js application to then generate more than just a single browser instance to do that call in a way that is compliant with the arguments that I put in there. So let's see if that actually works, even though all the screens will probably appear in the wrong place, which is my own screen, but I'll try to move them here.
You still have local host?
Yeah, no, in the... No, in here it's dynamic, so it's Janus CPU. Sorry?
9110. Top. Top of the file.
No, that localhost that you see here is just the default that I'm not going to care because I'm going to overwrite it with the command line argument. So, and then apart from this, I'm going to use localhost just to connect to the web page, I think, but not much more than that. So it should work, but let's see if I'm an idiot again. So let me see. Okay, just a second. I'm going to replace the localhost here with the right IP address. So I tried to make it look like a really stupid version of CPP, so using pretty much the same arguments, like the argument to specify the concurrent calls, the limit number, the max number of calls, the duration, and things like this. I'm trying to do pretty much the same thing, so call the echo test on asterisk using, in this case, 1 call per second, the limit of max calls at the same time, a total of 10 calls in general, and each call is going to last 10 seconds. So we can just try to start this. Then you can see that there are some things happening in here, and that's because I'm going to spawn. I'm spawning all these instances over there. Now you see a lot of noise because I have 5 browsers basically doing the same thing in an automated way. And eventually you'll see this application hanging up, which is an example of what is happening in all of these screens in here. So you get the idea, it's actually quite powerful. So let me stop this because otherwise I'm going to get crazy with all these voices in my head, which I already hear from time to time. And then basically, as you can see, it's actually quite powerful, but the problem with this is that even though it's actually kind of cool that there are tools that help you automate it and orchestrate a lot of browser instances, I'm not going to delve into this because it's not my field. Another guy in our team is actually very expert on this. But this is actually something that we've used a lot in the past also for some performance evaluations of our own gateway, and these are some graphics related to how the C plugin worked, for instance. So we generated a lot of codes using Selenium and try and figure out how Janus would handle these codes in terms of CPU performance, memory load, bandwidth, and so on, which was kind of cool, and also to do some cross-references to remote and local mixing and things like this. The problem with this is that you're still, even with all the optimizations that you can do, fake devices, frame buffer, and things like this, Selenium is still kind of heavy if you think about it, because a single machine can only handle and open so many browsers without actually starting to suffer from this. And this is also because all the actual media interaction is actually being done with actual encoding and so on. So you're actually replicating a real endpoint in this, which is actually kind of heavy if you're doing video, for instance, or stuff like this. There are only so many browsers that you can open on a single server. How many depends on the server that you have, of course. And if you don't have that many servers, then your scalability actually is limited. So for instance, it was our own case, because at the time we could only generate about 300 and something endpoints at the same time before we actually ended up with servers to use for this. And so we actually couldn't get a complete evaluation of Janus, for instance, for this specific use case. And in this case, then, if the user interface is only of a relevant nature, because sometimes you actually want to test everything, so including how your own application works in this sense, but are more interested in just testing the peer connections, then maybe a native tool can actually help, can actually do it better. So something that only implements peer connection and then leaves all the details about signaling and negotiation up to you, basically. So something that again should be controllable and programmable. So in principle, something like CPP, but for WebRTC, let's say, something like this. And something that, of course, should be able to send and receive media as well, so that you can evaluate things, things on your own in terms of quality of service and stuff like that. And while there are some tools out there, most of them are specific to target applications. So for instance, you may know the Jitsi Hammer is a really good tool that the Jitsi team implemented to stress test their own platform in order to evaluate whether it works fine or not under some numbers, but unfortunately it's really specific to the specific application that they have. And in principle, though, the Chrome WebRTC stack, if you take it as a library, could be used for something like this. So you could implement your own general purpose application that uses the library pretty much as the browser does, and in order to do something like this. When we tried to look into this some time ago, we didn't find any, so we implemented one on our own that doesn't use the Google WebRTC stack, but we basically extracted the Janus WebRTC core and inserted it into a client-side application instead, which we call JATAC, just because it was a kind of a nice mix between JATAC, that means I attack in French, and also because it gave the idea of Janus attack, because at the beginning we wanted to use this as a stress testing tool for our own platform. And it does exactly what we needed. So basically it allows you to generate a lot of peer connections by using a logic that is not within JATAC itself, but is part of an external controller. So the idea is that this tool can generate and receive a lot of peer connections at the same time. If you attach an RTP source that is external, so we don't generate RTP or media ourselves in our own, you can use this as the media that you inject in the peer connection, and then you get live events on everything so that you can monitor whatever happens. As I was saying, it was originally conceived for Janus, but considering that the signaling part is completely orthogonal to JATAC itself, it means that you can actually use it with other services as well, which means it could be used, for instance, to test other WebRTC services that are WebRTC based, and maybe your controller to SIP in order to handle all of this. And if you're interested in learning more, because of course I will not go too much into the details, there is a presentation that we made in Chicago last fall that describes all of this. And from an architectural perspective, it's kind of simple. So it's basically a decoupled version of CPP, if you will, because if we think that Janus is the service that we want to stress, and we have JATAC here that is able to generate a lot of pre-connections, all we need to have is some kind of a controller application, so something that is even scriptable, or a Node.js application, a Java application, or whatever, that basically tells JATAC what to do. So in this case, it would be, in the case of Janus, it would create all the sessions and the handles on the Janus side. It would negotiate all the SDP stuff back and forth, and then it would make sure that the SDPs, it would get an SDP from JATAC, use it to contact Janus, Janus would send an SDP back, it would send the SDP back to JATAC, so that eventually the communication is done here. And if it involves more components, the controller can take care of them all, basically. And this is the way it works when you have a media generator. So as I was saying, JATAC doesn't generate any media on its own, but you may have a controller that says, hey, spawn this video and RTP stream that I'm going to use for all the calls. It sends it via RTP, and then everything that is sent here is going to be injected in the WebRTC stream as well. So really, really lightweight for the needs that we had. And of course, this means that it's much more complicated than Selenium, because with Selenium you could just take exactly the same, the web page that you use, for instance, in production, or in the case that I've shown a demo, just script something to make some behavior automatic, and then you'd be done. So there was nothing else that you needed to do. The application would take care of all the application and signaling logic. In this case, all the signaling, so the fact that you talk to a specific server to authenticate, to exchange media, to set up a WebRTC peer connection, and so on, you need to implement it yourself, of course, which means it's less trivial. But if you're interested in just the media part and stuff like this, it's actually much lighter because, of course, you only need to take care of the signaling, of taking care of some web service connection and so on, which means that a single machine can simulate many more users than a single Selenium with some browsers on it can actually generate, which is actually kind of cool. And again, of course, most of the burden is designing the controller because you need to take care of the JATAC instances, implementing the signaling and stuff like this. But the cool thing about this is that considering that the controller is completely separated by JATAC, you can implement it in anything you want. So if you wanted to implement it in Python, you can do that. I don't know Python, so that's cool. This is a simple example of how you could implement a very simple SIP calling scenario with JATAC. So you would just say, create a session for me, generate an offer. Okay, this is the offer, these are the candidates and other events. This is information in a SIP invite that I send to a SIP proxy. I get an SDP back, and of course the proxy may involve a WebRTC gateway because this is a WebRTC connection. I get an SDP back, I pass it to JATAC. JATAC will end up establishing the WebRTC communication with the WebRTC gateway. I get a working call. I repeat this n times, 2 plus 2 per n times, and so on, depending on what I need to do. I basically replicated a scenario that can grow. So as you can see, quite simple from a conceptual part. And then, unfortunately, all of this that I've really explained in a GIF is actually not open source, at least not now, for a couple of reasons. One of those is that actually JATAC could even be seen as, considering that it's quite general purpose, almost a WebRTC denial of service tool. So, because it's really easy to just hammer the same server with a lot of stuff. I mean, it's probably a lame reason, but it's not really complete as of now. We need to wait a bit before we do that. But exactly the same concept that I explained so far, so all these kind of sequence diagram, all these concepts that I explained here and so on and so forth, actually apply to any kind of native implementation and so on. And so as I was saying, you could implement exactly something really similar, pretty much the same, using the Google WebRTC stack as the library to handle the WebRTC communication, which is something that a couple of projects have tried to do so far. So at least a couple of that I know of. These two projects over here, Node WebRTC and WebRTC Native, are projects that try to bring the WebRTC stack within Node.js. So Node.js is something that you can control and program yourself and so on. And so having the ability to do something like this within a Node.js kind of framework would allow you to generate a lot of scenarios in a very simple way and then leverage the Chrome WebRTC stack to handle all the media stuff and then follow exactly the same steps that I've described so far. And in principle, they look like they are good candidates for the job. I haven't dealt with them enough and so on, but from the conversations that I've seen on the GitHub project and some Stack Overflow questions, it looks like they are not ready yet, but it looks like they are really on the good path. So if I were you, I'd monitor these two projects to see how they actually perform and so on. And as I was saying, ideally, once they are available, you can reuse exactly the same logic that we've used for our own tests in JATAC, also for your own scenarios like this. And just to conclude my presentation, and then I'm done, one more thing that you could actually do, even though this isn't something that I have a demo for or something that I can demonstrate easily, why not reuse some of the servers instead to simulate all the WebRTC part as a client? Because if you think about it, all those servers, Asterisk, FreeSwitch, RTC Engine, Janus, or whatever, any kind of service that is WebRTC enabled, all have a WebRTC stack ready, so they can already negotiate WebRTC sessions with the WebRTC related endpoint. So why not use those to stress other servers instead? So all you would need to do is add in some kind of, again, a controller that can orchestrate all these servers to be used instead as puppets to generate a lot of traffic to then bridge the signaling towards a completely different service and then have them exchange media with each other. So as a very simple instance, I could use the Asterisk Manager interface or something more modern than that, because I'm really behind that in this case, to generate calls on Asterisk number 1, for instance. I get the WebRTC SDP, I use that SDP to call a completely other service, maybe with another protocol or still via SIP. I get the WebRTC answer, I send it back to Asterisk. So pretty much the same concept that we had with JATAC. For instance, we repeat it 10 times, maybe involving other services, our own fake clients and so on. This should result in all media channels that we can exchange with actual media being exchanged between each other, because both of them will actually do something meaningful. And of course, this is less flexible and probably less straightforward, but in principle, especially if you're quite familiar with any of these platforms above, and so you know how to orchestrate this in an easy way and in a straightforward way, this could be a good knife in your belt to actually do something cool in that direction. So I think that's so. So if you have any question, if you have any insult for me in particular, considering the broken demos and so on, I'm always. Thank you for listening.
Question, but only if you can ask 2 per second. Okay, so because I'm also curious, I haven't gone much into stress testing with WebRTC. Where you see like the bottlenecks so far is like this encryption decryption, or still the negotiation of the session, where what you try to test in most of the cases is like the parameters of the communication or the encryption, or where the most of the issues are exposed by the new browser or new releases of applications.
Yeah, in principle, let's say there are different aspects that some scenarios, different aspects and whose impact is important in different scenarios, because sometimes you may have transcoding involved, sometimes transcoding may not be involved, and so on. And so that also drives a lot the shift on how many people I can handle, how many sessions I can control at the same time, and so on with respect to this. But most of the aims of our own tests in that direction have always been of how many connections I can handle at the same time. So for instance, with respect to Janus, we almost never do transcoding apart in a couple of plugins. And so in that case, we were mostly interested in how many peer connections can I establish at the same time on a machine of whose characteristics I know, and so on. If the X is the limit, is there anything I can do to improve that limit? Is there any bottleneck, and so on? And from what we've seen, the bottleneck is mostly not much in terms of CPU and memory and so on, because typically even the encryption part is not really that heavy, because most of that can also be leveraged using hardware encoding and stuff like this, but it's typically mostly in the bandwidth. So if transcoding is the neglectable part because you're not going to handle that yourself, that's usually the driving factor. And of course, whenever you use applications like Selenium and things like this to test, transcoding is an important aspect because it is always happening, at least in an encoding part on the application itself, because even when you are using a fake device to capture something, you are still encoding media in the browser that you generate, which takes some resources and so on, which is what limits the number of concurrent sessions that you can simulate on a single machine, for instance.
Okay, thank you.
Thanks.
Other questions around? Okay, thank you, Lorenzo.
Thank you.
I'm sure we'll have more once we review the video. A lot of content, amazing. Thank you again. And next we have Sherman from Obihai. So we look a bit now on the client side of VoIP infrastructure, real-time communication. I think on the server side we have a good presence, a lot of, let's say, there are these core applications like Kamailio, FreeSwitch, but then there are wrappers on top of them, like, I don't know, Kazoo, FreeBBX, and many other CPOIs, platform C provider that gives you a full platform with web interface and so on. And I think what everyone feels when like a pain when running a service would be provisioning of end devices and how you control that, how you upgrade that. And Sherman here, I was speaking with him for a long time, and they really solved it nicely, and I asked to present because hopefully other vendors out there will come up with some easy to deploy solutions and control your endpoints, because my mother will not be even able to restart the phone, so I just say unplug it, right? Don't go on the menu and do a soft reboot, just unplug it from the power and that's it. But then it's always a lot of situations when you need to do upgrades because of the security releases. You need to enhance some of or tune some of the settings. Maybe you bring a new feature on the server side and you want to enable it on the client side now, because if you just let everything enable from the beginning, people go crazy seeing a lot of options and clicking and then nothing happening. So it's going to be taking a bit of time to set up because it's going to do some demos. So has the phones and stuff.
Daniel, can I share a...
Okay, we have James that wants always the microphone.
Always want the microphone. Yeah, a little known fact about Sherman. All of those in the audience who've had a Sipora or an OB-High device, until very recently, Sherman was that voice of the ATA. So when you press the star, 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 and it goes, Emperor, configuration, menu, that was Sherman. But Sherman is so shy and concerned about it. I think it's been replaced by a lady's voice, and that lady is not Alison. Shame on you. But Sherman was that voice. He is famous.
Okay. Yeah. Sipura actually was one of the very good phones in early phase of SIP as a protocol. It was bought by Linksys.
Cisco.
Cisco. Yeah. I don't know the order exactly, but they ended up with Cisco. So Sherman was with Sipura. Whoever remembers that nice old phones. And now it brings the next generation of the high phones. Probably among the first having this wideband codecs, including Opus, and quite a lot of nice feature. During these days, Sherman will be at the demo outside, so if you want to see a demo, take the quality of audio and so on of the calls, just go there. No internet connection, and again a reminder, if you are on Wi-Fi and is not connecting to the first network that we advertise here, there is a second one, FAG Guests, which requires a different credentials to log in, flyers on the back or ask at the front desk. So if you get troubles with accessing the Wi-Fi, there is a solution for that. Go at the front desk and ask for or just take the flyer from the back.
Alan's headed off to the US, so there is no better.
Well, afterward. Do you work for them?
Okay, switching networks, live.
And SIM.
SIM.
Tomorrow we're gonna start like 9 a.m. So I'll remind that later. So sessions typically half an hour sessions and some coffee break, lunch catered here for you with some buffet, good selection. In the evening again we'll have the cocktail party also outside, so everyone can chat with the others and enjoy a bit of German beer, some good wines, and a bit of finger food, so everyone can move easily and discuss with the others. And probably one of the very important outcomes of such events is to really make connection with the other guys around you, because a lot of content here is also open source. Of course, it's good to see how people use it, and what is more important to get also like personal connections out of this
okay, so
event.
Because the network I should serve systems on video research.
Yeah.
Okay, so some. Then before the social networking event tomorrow, we'll have Randy again with this panel, open discussion panels about the state of real-time communication in the future. So that's kind of open discussion. Anyone from audience can participate. We'll get some people in front, but you are invited always to contribute. And then James already mentioned, but whoever came a bit later will have Dangerous demo again. Just before lunch on Wednesday, so the last day before lunch, because it proved to be quite entertaining and people have a good appetite after that.
Just like a minute.
Sessions, some interesting session. If you haven't met yet the voice of Asterix, Alison Smith, so she will be here tomorrow with a presentation. And it's your chance to get a good deal for recording your tones for the PBX or for your home. So you are calling me and I'm not taking your call, of course. Then a lot of other industries, from the RTP engine to WebRTC, security. We have again Sandro from SIPVicious, also known as Friendly Scanner. So he's going to present some types of attacks and how that could be prevented or protected.
There's something dangerous happening.
We have Ole here early morning because he wants to start fresh, presenting about the use of Kamailio in broadcasting industry, Swedish radio. I don't say more because I let him disclose.
Okay, we're good.
Okay, so we set up. Just to finish before this, don't really look only at the speakers because there are many in the audience with really good background. So we have also like developer of RTP proxy. Maximus here in the front would be the Zoiper guys, and again plenty of other developers from Kamailio, Miko with unit testing and a lot of contributions. We can't really have everyone speaking, but the audience is packed with people that really do stuff with VoIP, not only like deploying it, but actually building stuff. So now we have Sherman ready to go. Quite fast infrastructure setup, I would say, just coming and unpacking here and plugging everything ready for production.
Yeah, just wait until you see what he's going to do for his dangerous demo.
Yeah. Okay, Sherman, thanks for coming again. We Heights supporting the event, and we're glad to have them back here in Berlin, and they have really nice devices, and hopefully what they are doing is going to be adopted in a way or another with others to make the life of our deployments easier. Sherman, thank you.
All right, thanks, Daniel. Yeah, my name is Sherman Skolton. I'm with OB High Technology. This is our third time at Kamailio World. We missed last year, but we're here the previous 2 years. Like what Daniel said, we make endpoints. We make analog phone adapters and we make IP phones. And what I'm going to show you today is an API that we put together that is partnered with a web portal. So they the two kind of go together. And in essence, all the functionality that's on the web portal and more is being brought forward into this kind of RESTful-like API. My email address is there, so feel free to contact me anytime with questions. I did not code the API. I didn't code up this demo. A couple developers at OBHI helped me do that. But I think I can show you guys the meat of it enough to make it interesting to you. But again, happy to answer any questions to you. Any questions for you here at the forum, or go ahead and send me an email. Also, this demo we've put into a zip file that you can download and check out the examples of the JavaScript that's in there that's being used to exercise the API. That's at the fw.obhi.com/kwdemo.zip. And then also we have a document that describes what we call our device management platform. This is for primarily service providers and system integrators that are looking for endpoints that can be managed. One of the things that we're running up against is as these IP networks, these real-time IP networks are built out, they're all different kinds of endpoints that people want to connect to them. So, just had a great presentation on how to test, WebRTC clients, from I guess a browser point of view, but it could be on a lot of different devices. But what OBHI does is we make an embedded platform hardware, and that can fit into a lot of different services and into a lot of different places. Carson talked about voice over LTE. We have a lot of service providers coming to us today wanting to use our endpoints with VoLTE networks, both for PSTN landline replacement, great application for LTE, so how do you send fax over LTE? How do you open a door over LTE? How do you just have an analog phone conversation over LTE? So we're doing a lot of that today, all the way to the desk phone, where there's a lot of activity today in this kind of small business hosted space where I think, again, LTE is going to make a big impact. Vodafone has a service that they're pushing hard that's a converged voice and data service over wireline or wireless, and in the US, Verizon's doing the same thing. AT&T is soon to follow suit. So there's a lot of activity here, especially in the small business space. Daniel talked a little bit about OBHI. We've got a long history in this space, going back almost 20 years now to some of the very first voice over broadband endpoints. And right now we're taking, I guess you could wonder what's new and innovative in the hardware endpoint space. Well, we're taking this cloud approach and this platform approach towards management. In old kind of telco speak, there's this term FCAPS. And let me get to my FCAPS, a couple service providers. So FCAPS is, like I said, an old school telco term, but it was something that if you were going to launch a service, you had to have your FCAPS story solid and bulletproof before you could even talk about what you're actually going to sell to the subscriber. And so FCAPS stands for fault, configuration, accounting, performance, and security. So we all approach that from different angles today using different tools. And what OBHI is doing is trying to provide endpoints that kind of come pre-packaged with interfaces so that service providers can have this FCAPS element to their to the endpoints that they're deploying. And this is really the type of thing that you really have to tackle when you're talking about millions and millions of endpoints that are on the network. And it's one thing to be able to strictly control it from the standpoint of a standard like that's in 3GPP LTE, but then oftentimes, especially if we're talking about a lot of these over-the-top type scenarios, which some of these tier 1 service providers that I'm talking about are doing is there's not, you kind of have to approach management a different way when the service is running over the top. And then this also gives us another opportunity to take kind of latest advancements in big data, analytics, grabbing all this information and using it to provide a better service. So at the beginning, we need to provision and bootstrap the devices, and there's lots of flexibility that typically needs to be built into how you do that with a device. And a lot of it then, that's kind of the day zero problem that we're solving with bootstrapping, and then the day one and beyond problems of customer support, this FCAPS interface also assists that. So what we have is a cloud that we built for the endpoints that we refer to as ObiTalk, or the ObiTalk device management platform. And then that plays in concert with other interfaces that the devices use for things like their connectivity with SIP or other provisioning servers. And at ObiHi, we started to solve this early on because as a startup company, we're bootstrapped entirely internally by kind of angel investors. We have no outside funding, and so the path to profitability as soon as possible was very important. And so since we are pretty good at making these endpoints, what we did is first made an analog telephone adapter endpoint, phones take longer, and we basically started to sell these things to anybody that wanted to buy them. And we went to online merchants like Amazon.com and started to sell the devices. And then along the way, a couple of our engineers figured out how to get the devices to natively connect to a service provided by Google called Google Voice for free. And this basically provided people with a free phone number. And as long as you use our device to connect your regular telephone with your Google Voice account, well, there you have a free telephone. So that really helped the company grow and put more money into this cloud platform with the main idea that we were here to serve people like you. We were here to, the idea of the company was to build a better mousetrap in terms of the endpoints with a focus on provisioning in the cloud. So this portal that I'll show, this API that's underneath the portal, most of that is used every day by hundreds of thousands of people who have gone to Amazon and bought a little device to use with their Google Voice account. So that's really helped us, you can imagine to have real world users that are exercising this configuration and management portal every day that can, really help you strengthen it and harden it. So the first thing is, how do you add devices so that they can be managed, so that they can be bootstrapped to your platform? And there's ways that we've created where you can manually do it, so especially for those BYOD people, those people who are going to bring their own service to their device. There's a manual way to sign up at obitalk.com and then add a service to your device. Same thing for the service providers. If you just have a device that you grab, there's a manual way that you can do that. And the whole idea here is that you get that device into your management domain, you bind it to your account, and then you can do things like add services, like monitor services, and exercise it with the API. We also have a approved service provider program. This is where people who get their device from anywhere, from Amazon, from Newegg, from whatever, as a gift, they can go and use this ASP program to attach a service to their device. This one is a little bit, there's an API underneath this that works with the button on our web page, our consumer web page with your service. So it makes it really simple for somebody who knows nothing about SIP, who knows nothing about a SIP username or password or proxy server. They just click this button, we tell you about the subscriber, we let you sign them up, and then you send back basically the bootstrapping config. You could even send back a full config if you want to the device. And then where things start to get, I think, more interesting is where your business model is more of a, you want to deliver a device to a customer, they just plug in the power, they connect it to the internet, and it's good to go because something has happened either before the device arrived and got installed, or something happens right when it gets installed that allows this automatic binding of the subscriber to their device or devices. And this is a very straightforward way to do it when we do it direct. We can scan the MAC addresses of the devices, put them into your device management platform account, and then they're there. You'll see them as pending. I'll show you a screenshot of that. The other way is if you get the devices from a distributor or for whatever reason you don't see them in your account, then you can claim them into your account by just putting in information about the device, and you'll be able to bring them into that zero-touch mode that way. And we also have something called the SAC, or Service Activation Code. This is used by several service providers today, where the customer receives their OBI device. The service provider doesn't really care which device they received, because at the time they get it, they go to the service provider's webpage, say, activate my device, follow some instructions, dial a code on the phone, and their, like I said, their subscriber account is associated with their device. This isn't coming out that great on the portal or on the screen, but this is the web interface of the portal. So basically, we're showing a little bit of information about the devices, their online or offline status, and you can just click into the devices to manage them. I'll show you that in a second. Like I said, if you want to add one manually, you just, on the left-hand side, there's an Add Device menu, and then you just follow the instructions to add the device. You basically dial a code that will uniquely bind a unique code that binds that device to your account. And in the case of a phone, you'll see a little message pop up that says that you've added your device. You confirm it on the web page, and there you go. I talked about the ASP. We have several service providers that have a button on the ASP web page. You could too, and that's where somebody comes to our page and selects your service. And then we've got the zero-touch modes, which either they're coming directly from us or a distributor, and they've been pre-assigned to you, or you've received them and you've got the ability to claim them in to your account as a zero-touch device, or the service activation code. So here, if we have provided you with devices directly or directly from a distributor, you would see the devices ready in your portal and with a ZT pending status. And then again, there's an API associated with this, where you can also have a machine query your database, basically looking for the devices that have been added in there by either OB-High or a distributor. And these are kind of your stock, your inventory of devices that are available to be sent. Now the claiming, in the case of a direct ZT, we basically have claimed them for you, or you can claim them yourself. You basically go to the claim device area. You can do it one by one with a MAC and a serial number, and then choose the ZT profile that you want to assign to that device. Different phones, different customers, different devices might have a different ZT profile. A zero-touch profile is essentially just a bootstrapping config that's going to do whatever you want the device to do, and it also becomes it also has some permanency to it, in that it becomes the device's default setting. So if that device is ever a factory reset, it will come back and behave that way as well. So this is the claiming screen. And then the service activation code. This is a screenshot from a customer of ours called dialpad.com. They use the service activation code. And there's kind of two modes. One is, did the device get assigned to the service provider in a ZT mode, and then they are able to show just an activation button on the screen of the phone, and they just click activate, and then on the user portal, they're telling the user to enter an activation code. Or if the person went to the store and bought the phone themselves or got it delivered by Amazon themselves. Then they actually have to do a little bit more work. They have to dial a specific access number that's associated with that service provider, and then enter the activation code that the service that they show. So what happens behind the scenes is when they use the service activation code, the service provider calls the ObiTalk API, the service activation code API for activation code, and then they can show that code to the customer. The customer then enters that code in the phone. Either they connect the phone to a service through this ObiTalk connection, or it's predetermined because they've got that activate button on there, and then they enter the code, and then we send back a response to the service provider that the code that this user entered is valid, and here's the MAC address and the model type that user that they already know is logged in has used. And then that allows them now to send back another bootstrapping config, just like the ASP API does as well, and then they can go ahead and bring the device into service. Okay, so underneath this, so that's kind of what it takes to get the devices into your domain, into your management domain, into your provisioning domain, and then now it's up to you how you want to use the management interface going forward. One of the things that you can do with the API is, let's say you're using Kamailio, you're setting up subscribers in Kamailio with an extension number and a password. You could also create a kind of some glue in between that and the ObiTalk API to now go ahead and assign that user, that extension, and that password to an account on an Obi device. So the ObiTalk API is a service interface. Your machine logs into it with a username and a password. If it's right, we provide you a token. With that token, you can go on and perform other functions. So as a client with an authorized token, you're able to query the types of device models that you have or that you have available to you. We have a concept called base profiles. This is a basic configuration, much like a ZT configuration, that you can assign to a device, that it'll pull it down from the ObiTalk device management platform. And you can also fetch which base profile is assigned to a particular device or group of devices. There is a sub-account framework or a sub-organization framework in this platform as well. So you can do that, say, okay, for this customer, I want to see what their base profile is set up, or I want to modify their base profile for all their devices. And then we can also fetch what the state of the device is and samples of various configuration values that are on that device. So you can really use the API and the management tether on the devices for a lot of different uses. This is very handy in the case of if you don't have SIP connectivity yet to the device. So with, for instance, many of you know that with a SIP notify, you can invoke a lot of things on clients, like to reboot them, to report their config, to report their status, but you have to have that SIP account set up. And sometimes devices, for whatever reason, lose their connectivity with the SIP server. It could be a ALG in a router, firewall, some weird networking scenario that's going on locally, but you still have, in many cases, you'll still have this management tether to the ObiTalk device management platform. And so this is where you can use the API or use the portal to do things like, for instance, simply reboot the device. So let's see, I'll take you through this in an actual live scenario, but getting this token, identifying devices, rebooting the device. So now, let me go to the portal here. So here, for instance, is a device that looks like we've got So this is, I believe, this phone here, this OB 1032. And right now, I already had it configured to connect with this Kamailio instance that's running on my computer. I haven't started it yet, so right now it's failing register because there's nothing for it to register against. But this is what the management portal looks like for an individual phone, where you can see it can have up to 6 SIP services running on that phone. You can assign the services to the buttons, for example, if you want to do that. You can see a little bit of the status, MAC address, things like that. This is where you can do things like assign it to a particular organization I talked about. This might be customers of yours, it might be resellers that you have set up, that you want to place that device into an organization. Once you do that, each organization can have its own member users, and those member users have various capabilities in terms of managing devices or managing base profiles. And you can extend that to your users, and they can only manage devices in their organization. Of course, the top level service provider has access to all the devices and all the organizations. One also nice thing that we've got is if you want to use the ObiTalk device management platform as a provisioner, you can do that, and we have what's called the ObiTalk configuration. This is an actual config that's hosted in the cloud for this device. Now, you don't have to use this. You can use your own provisioning server if you want. But if you do use this, then this is nice because this stores the profile in a safe place in the cloud. In the case that you ever have to wipe out this phone, it'll come right back and download that config. And then also, this is nice, this local configuration. I can actually get into the web UI of this phone, and I can see what the actual running parameters are, how it's running, how long it's been running, what firmware it's running, and I can confirm that parameters that I've provisioned are indeed, those parameter values have indeed taken, and are what the product is running with. So right here, I'm actually looking at the web page in this device. I can go ahead and go to its IP address, just to show you that it is at, what's it say here, 101, 10.101. And I'll go in here, 10.101. So, this is local. This is if I'm local. This is what we're all used to for the past 15 years of these devices. And then where this is via the cloud. And so you're not always in many cases, you'll never have access to this local config. This phone is out who knows where in the world. But you can get to this same interface via the cloud piece. And this is really for more inspecting the device, not so much for configuring it, because you'll either use your own provisioning server or you can use the ObiTalk provisioning that we provide for each device in the cloud. And then here, if you want to reboot the device, you can even from here go ahead and click reboot, and then if everything's working, this guy will go ahead and reboot. Okay, so now what I'll do is bring up the Kamailio. Let's see. So that's what I'm in this box. Start this. This doesn't take too long. Okay. So I've got this these demos in our studio that was made for this. Okay, so I'll go ahead and start. Let's see. Okay, so let's go ahead and start, and if these guys will eventually register, now that the Kamailio server is up and running. This guy was having some issues before. I saw he was offline. Let me see if we can get this guy to come back online. Okay.
Yeah, network's been difficult and refusing to give out IP addresses.
Okay, well, hopefully it'll come back here. Now what we can do is go ahead and I will go to the, I'm going to actually go to the portal API. There's a document on the portal called Service API, and you can actually bring that up, and it's a live document where you can run some operations. So I'll go ahead and in here and create a session for this guy. And then, let's see. Do a live request. Paste. This guy. Password.
That's a password that needs changing.
I think that's right. That's not the right password. It's 1997. What's that? Oh. Quotes. Oh, it doesn't need quotes? Yeah. Let's see. Okay, there we go. Okay, got the token. Now, let me go and check out the devices. Let me list the collection of our devices. And I'm just going to look at the, I'm going to also list the OB number. So I can list the OB number, the MAC address, serial number, the organization that it belongs to. Okay. And then let me grab the, I know it's towards the bottom here. Oh, it looks like this guy came back too. This device's OB number is, ends in 472652. Okay, that's it. So that's its device ID. And then again, like here in the here's an API live request, for instance, to go ahead and reboot that device. So what this will do is create this URL for the API. Go ahead and do that. So that was just like what we did on the 72. Yeah, there we go. So then that just rebooted the device. Okay, now back to the. So let's say if I am going to set up a Kamailio device, let's say that I want to configure. Let's say I want to change the password in the OBHI device. I can go ahead and go to the device that's using, let's see, that's 3000, that's extension 3001. And I'll change the password to 1111. Okay, so what this just did is it's going to the ObiTalk API, just like what I was showing on the live document. It's creating a session. It's going to find that device that's the user 3001, and it's going to change its password. And then eventually this device will become unregistered once it tries to re-register with the Kamailio. I'll go ahead and do it with this 3002 unit as well. Okay. And so this is just showing, updating a configuration on a device, and this is definitely a powerful use of the API. You can use the ObiTalk API to push configs to the device. Like I said, you're setting them up in Kamailio, and then you're packaging them up and putting them and sending them to the ObiHi device. But then the other thing is pulling information out of the devices. So pulling statistics, not only configurations, but very soon you'll also be able to pull things like call quality data, network quality data. And so this is another point of truth to be able to troubleshoot network problems, site-specific problems, device-specific problems. So let's see, then we want to go now to I think I gotta wait for these guys to go. Also want to go back to this guy. I'll go ahead and
there it goes, rebooting.
And then let me go to just the collection of devices. I'll go ahead and get the device ID for this guy as well. This is Obi number 630187950. Okay, that's this guy. I'll go ahead and reboot him. Okay. And then let's see. Let's see. Okay, so you see these guys just became unregistered. And now because I just changed the password in Kamailio to 1111. And now to go to the device and let's see if I don't get lost here. To do the unit, go to thought that did that. I think there might be a little bit of a network issue. It's causing us to delay a little bit. But okay, that one completed. Throw one. Change the password there. Okay, so then it's basically going out, again, it's going out to the API, creating a session, pulling down the config, matching the config and the config types, and then going out to grab the parameter value, update it with the new config, and then here's each configuration has an associated numerical ID to keep track of that, and what its default setting is and what values it's at. So here it shows changing the extension of the extension 3001 to a value of password value of 1111, and then it will eventually go out and update the phone. I think part of this is the registration retry interval that these phones are using right now, which is why they're taking this amount of time. So change user Kamailio, and then let's see, this one, 2222. Okay, so I didn't change that to 1111, I don't think. And 2002. Let's see, that was this was Mac at this ECC. Okay, that one's rebooting now. So I think that this one just got the new password, and this guy is MAC address. Okay. Update the password in Kamailio to 1111. This guy rebooted, came back, registered, and then this guy's now unregistered, and in a second here he'll re-register with the he's got the right password, and he'll now register successfully with the right password. And I can't remember what the re-registration is though. We'll take that one. Okay, so okay, and there, yeah, he's registered now. Okay, so that's all I wanted to show today, was something as basic as changing the password on the SIP account. But like I said, there's literally about 3,000 parameters that can be touched on the device using this API. as on top of grabbing statistical information from it for its online status, its uptime, its firmware version, really anything about the device that you can gather from it locally, you can get via the API. And then for those of you who are interested in this, we have free units that are available. Just come see me. I'm waiting for a couple of packages should have arrived on Friday, but having some issues tracking them. So if they don't show up, don't worry. I'll get you guys devices that you can try out in your own environments. But this, from the standpoint of, I think, innovation in this industry, obviously there's tons going on with iOS and Android and WebRTC, but a lot of the endpoint action in this industry still resides in these embedded products, and especially now that the service providers and the marketing people at the service providers are ready to actually start promoting IP services for real-time communications. It hasn't always been that easy. So thank you very much. And like I said, come by and talk. I'll be at a table outside for the next couple of days. Thank you.
Questions? Anyone? Ole? Okay.
Yep.
Ole loves devices.
Sorry to have to be the boring type, but you're hosting a lot of data on customers, which according to European privacy laws is covered by the privacy laws and can't be exported. How do you handle that kind of situation in your systems? I notice your servers are up on Amazon, right, somewhere.
Yeah. So right now the servers are on Amazon in the U.S. And on and I think that's fine for the most part for companies that are in the U.S.
Yeah.
But for companies that are here in Europe, there's kind of, as I understand it, there's kind of two modes that are potentially acceptable. One is to have it at Amazon, say here in Germany, and then the other one is to completely disassociate the customer data to a server that's owned by the customer. It doesn't necessarily mean that they can't use the API in conjunction with their devices, but like you said, the customer-specific information needs to reside elsewhere.
Even the IP address is customer-specific, privacy-protected information.
Okay.
Okay. Hello. So some of the protocol behind the scenes running there to communicate with these devices, namely behind NAT, are you using some kind of TR69 for like requesting the device to reboot itself or to report some data back to the cloud? What exactly are...
So it's a combination of things, but primarily it's just an HTTPS connection to the device. So fairly NAT friendly. We do have though a whitelist of servers and domains that need to be taken into consideration for to allow this to work. But for the most part, it works. It's very
so when I log into the cloud platform and inquire the phone to send me data, in that case, is the phone like on a separate process reporting like every second or so, or do I actually inquire the phone in that moment to report back the data?
The phone maintains a registration with the ObiTalk device management platform, and then we can kind of, tickle it with a request.
It works like a VPN over HTTP, something like that.
Something like that, yeah.
Okay.
James.
rushing to me.
Draw very active.
You touched on the fact that these Obi phones are one of the few phones that actually support both Opus and AMR wideband. Can you just explain a little bit about the use cases that you would anticipate?
Well, you know, a couple of years ago, we started working on these phones, and along with that, you know, at ObiHi, the development team can develop down to the DSP level, so we can put any codec you want on it.
Yeah, just to clarify, when we say Opus and AMR, this is the full variable rate, or is it fixed rate?
Today it's variable rate. The very first release, it wasn't, but then a few months later.
What fun we had with that.
Yeah. And so the idea there is that with Opus, we do have a lot of service providers who are running an over-the-top service. They have standardized on Opus for both their soft phone, mobile, fixed soft phone, as well as their IP phones. And that way, they're able to maintain a higher level of voice quality between the devices, regardless of, you know, especially we've noticed Opus is obviously very wireless friendly. Wireless network friendly, and so many devices are on Wi-Fi. Our devices actually can run on Wi-Fi as well. Opus tends to perform better than other codecs that are out there, and it's royalty free. Although a lot of service providers continue to use G722, and the majority continue to use G711. For AMR, that's kind of a new thing.
Not in the mobile world.
In the mobile world?
In the mobile world, everybody's been using it for years. But
they're using it for years, but it hasn't really been deployed on desktop clients yet. And so now with primarily voice over LTE and the desire to take the transcoding out of the connection, I think a lot of it is some for performance, a lot of it is for cost. The SBC guys charge a lot of money for transcoding AMR to X. And so we've had a lot of requests to have AMR directly on the endpoint, and we've done it. We have it available today for testing. AMR is one of those codecs that costs money. If you're Samsung or an Apple, you know, big deal. But when you're ObiHi, we need to really understand what the opportunity is before we actually put it in a production release.
And was I the first to ask for it?
You weren't, actually.
No?
You were close, yeah.
Then one somehow related question on media processing. It's ObiHi supporting like WebRTC encryption, so I can call from web browser to an ObiHi without encryption of the RTP?
I believe that's possible. We do support a WebRTC client, actually, and server on the device in a WebSocket implementation, SIP over WebSocket. And so along with that comes some security. Yeah.
Okay. Last question, if any. Okay, Sherman, thank you, and don't forget to pay him a visit. He's gonna be just outside at the
Rolls-Royce
exhibition spot. Hopefully the delivery will arrive soon. And now let me introduce next speaker. First to set up.
That's rubbish.
That doesn't sound right.
No,
We're talking about fixed.
Yeah, but the fastest standard signals, if you're close in to the of boxes is 80.
I thought Andy had some ridiculously high.
Yeah, but Virgin got a cable service that is faster.
Yeah.
But in real time...
Is that what he has?
Yeah, but it's so heavily contended. In real time, the channel may be up to 200, but even so, that is only, I don't know, 10% max of the population, if that.
This is, you're talking about fiber in the cabinet?
Yeah,
Which would be
no,
common.
fiber in the cabinet, the fastest service we've got is an 80. 80.
Okay.
That's
many megabits.
Yes. So the Virgin cable service goes faster, but that's only available to a small proportion of UK population.
Yeah, 51% sounds like a lot.
Yeah, it's rural. It's focused. So you go back to them and say no, your numbers
Well,
are
I have to remember where I saw that.
Take
You
rubbish.
don't know that name though? He's constantly
He's not.
Okay, so hopefully we're gonna be ready soon, as my next talk is on Kamailio configuration optimizations, and anyhow we do quite good job at the performances. So I will not have any interactive demo now here, but I will give you some tips, tricks on whenever you need to optimize a bit more. And here it's about caching, also some parameters of the configuration file that can help you, and also quite important how to discover which part of your configuration file is a bit too slow for what we would expect for a large deployment. So again, I'm Daniel Konstantin for whoever I haven't met yet. I'm one of the main developers, or pretty much the main one at this time. But for those that don't know the history of the project, I will have tomorrow in the first session a bit of history. So now let's focus on the technical side. As I said, more on tips and tricks about optimizing Kamailio configuration. How many of you know Kamailio configuration file, or maybe how many don't know it? Okay, nobody? Then it's good, because you know it's actually a scripting language. And my last talk, just to make myself a bit of advertising, will be about the scripting languages, because now we are transitioning to a more flexible way. So this is actually about the native scripting language, which we kind of built from scratch, and it's still there, still widely used. But with all this dynamic world with web, RTC, or real-time over the web and other mediums, we need to get a bit more flexible. And again, the last talk of the event, whoever resists to Wednesday evening, I'll have a description of what you can use now. So first to look at its latency. So what's slowing down? You have this beautiful configuration file, 20,000 lines, right, zip-wise, or Kazoo, or whatever other large deployments are out there. And then maybe it's not that easy to spot what's really not running that fast. So if you look at the core cookbook on our wiki and you search about latency, you'll discover a couple of parameters that you can enable or set some values for them to get some, in our case, log messages in the situation when some action, as we call these statements in our configuration file, are too slow. First would be the latency CFG log. So this is about printing the execution time for the main request route or the main reply route. So that will be like the root route block in our configuration file. So what's executed for a request, because it's a chain of actions there. And maybe you just want to get, okay, now this route block took that time to be executed. This is actually rather new because I introduced it to check the performances of native versus Lua or Python or other scripting languages that we have now available. Maybe more related to this specific action would be the latency limit action. Here you can set a threshold upper limit in milliseconds for the execution time, and if exceeded, so if one action is taking longer than this limit to be executed, you will got log message. So practically you can see, okay, now the lookup location is slow. Maybe I have so many active users that I need to increase its hash table or do other kind of optimizations. Because we do quite a lot of interaction with the database and there are some modules doing a couple of queries, we have another latency related parameter, the latency limit dB. So this is measuring how long it takes to do a database query, no matter it's Postgres, MySQL, even DB text, and doesn't matter which module does one or many, it's for each query. So this is quite useful to detect whenever you have some maybe not optimized database, so not proper indexes or unique keys or too many records. I'll get later to it. And somehow the related, like not specific to latency duration, it's latency log. This would be, which would be the log level where printing this latency related messages. We actually have a dedicated module, so that's part of the core, but then we have a dedicated module where you can enclose which part of your config file you want to track into two actions or functions like BM, so benchmark start timer, and BM log timer. You can use as many timer tracking IDs. So here we want to know how long it takes to execute the lookup location. So practically the action would be with the limit in the previous slide. Here you want to see it, and this is doing more than just printing the execution at one time. It's also keeping a bit of history, so you get some average printed. So because if you have a lot of traffic, you'll see, okay, the user lookup took in average so many milliseconds. You can even compile it if you have the real-time library to get nanosecond precision for the execution of the config file. In between these two functions, you can have many actions. You can call route blocks, so it's not only for another action. So it's up to you to put as much as you want inside the start and log timer actions. And one way to discover which part is slow when you don't know, it's like splitting into start stop or start log at the mid of the request route and then another start and stop at the end of the request route. And then you discover which one is slow, and then you keep splitting by two sections until you get and discover, okay, maybe some database related, maybe some DNS related issue, and if it's like T-relay takes too long, that's typically because of a DNS issue. Or if, I don't know, auth is taking long is because fetching the password from the database takes too long. Or maybe it's accounting, writing, and so on. Because we interact a lot with or all this feedback is mainly through the syslog. Be aware that syslog actually is slowing down a lot. There are people, especially at the beginning of the learning phase of Kamailio, they tend to put a lot of log messages because they want to see what happens and have for each request coming to Kamailio a lot of log messages. If you forget to set it in asynchronous mode, the syslog, this is becoming a bottleneck because practically the library keeps Kamailio blocked until the log message is written and confirmed to be written in the syslog file. Depending on the syslog application that you use in your operating system, there are different ways to do it. I think this is for the classic old syslog. Practically, you have to put a dash, a minus in front of the log file to make this like an asynchronous writing to syslog. Different other like syslog-ng or rsyslog might have slightly different options, but the takeaway here is be sure you configure it in asynchronous mode and the syslog demo, the syslog application. Of course, would be recommended to direct logs from Kamailio on a dedicated log file. Each of these applications, they have their own mechanism. They rely on this facility ID, in our case local 0, and you'll need to also set it up in Kamailio config file. So this is what we provide as tools inside Kamailio configuration file that you can use to discover what are the slow parts of your configuration. Next step might be that, okay, I discover it's authentication, it's accounting, you will need to do optimizing of this operation or what's behind it. As one of the old good friends from voice over IP now no longer doing, who is knowing Stefan? Okay, so a lot of new people I haven't seen him. So he was also involved a lot in voice over IP with the Gemeinschaft PBX. So cache is cache. So it's important at some point to go beyond what C code can optimize for you. As a summary, so there are a couple of modules that they do always database interaction, like authentication, DB, alias DB, group, speed dial. These are always fetching data from the database. So a way would be to optimize this, and of course some generic SQL related modules like SQL Ops, obviously they interact with the database. Of course, first and very important is to have a optimization of the database itself, the table, so proper unique keys, indexes. Also don't keep like unnecessary records there, especially if you're a large deployment. It's good to move from one table to another. I've met a lot of issues with like people keeping accounting for 1 year in the same table, although they already billed and so on. It's good to have it for historical reason, but don't really keep it in the same table where Kamailio or the SIP server is writing. Also for some operations, because like accounting maybe makes sense to have it in a central database and it's a single operation, but I have seen companies liking to do a lot of database oriented routing, so having like a store procedure for doing list-cause routing, that's fine. Provide a couple of parameters, source IP, caller, callee, and you get next IP address. And they do it as a store procedure. But then if you keep like a centralized and that's a slow communication and you do it a couple of times for each request, that could be slowing down. So it's good that sometimes you move closer to your SIP routing engine. So you split between what needs to be collected in a central point and what's needed locally for routing. Different database systems, they have also this option to declare tables in memory. So sometimes this could be good, or the other generic option would be creating an in-memory partition and any kind of database server. Then if they created there, should be faster than the usual hard drive. This is getting lower and lower as required because we have this SSD which is trying to be quite fast right now. But anyhow, back to Kamailio and what you can use to optimize or cache information. We provide you a few modules. So we have first here hash table module, and somehow I got to the saying that if you don't have hash table in your Kamailio configuration file, then probably you are doing something wrong. Because it's really useful and it's also in the default config file for detecting attacks and blocking them by using a hash table. So what's this module? It's like a generic module offering you options to create as many hash tables as you need or as you have physical memory, and then store these key value items inside it. It's up to you to define like a table name and what you store inside it. And this module has a lot of attributes that you can tune. You can set like maximum lifetime for a value. You can set also auto expire if not used, or maximum lifetime will be like if it's even used, expired after a while. You have some function or variables. You can count items by matching the name or the value of an item. So you can get the reports out of it. You can delete by matching, so regular expression matching of some keys or values inside. So it's quite useful. If you are not familiar with the hash table concept, it's practically a list of lists. If you look at Wikipedia, there is a very good article and very easy to understand. So if you are not a programmer, you'll get a good idea. And practically, most of the database indexes, they use the same concept of like hashing of a key with a function that results in an integer or numeric value, which is then used as a modulo over a modulo number of slots you want to have in the hash table. So it's optimizing the search of values. The module is also offering some event routes, so you can initialize values inside the hash table when Kamailio starts, or also getting an event when some key is expiring in the hash table. Again, it's very flexible. That's a common, like, generic purpose module. How you use it, it's up to you. Already mentioned that the default config file, use it to block IP addresses when detecting it's like a flooding attack. And next slide, I'm trying to show you how you can add caching of passwords. So as I mentioned, authDB and authcheck, that's function exported by the ODB, it's always going to the database and makes a query. You have a registration, you have a subscription, you have an invite, you want to authorize, even if it's the same user, then this goes to the database. What happens typically, there is a burst of messages after registration, like subscription for BLF and so on. So might be a good solution to just cache it even for a short period of time, like 1 minute, half a minute. The password with the first registration, of course, when it's a successful registration, so the next one that comes very fast, subscribing for all my contacts, will get it from the cache. So practically, we have defined here a hash table, size 10. This is used at power of 2, so practically there are 1024 slots. So the number of slots is 2 power, the value of the size. And we say it's expiring in 5 minutes, 300 seconds. Again, you can tune that as you need. Another quite interesting trick that you can do this time on authDB is this load credential parameters. If you haven't used it, look at it. Maybe you can use it also for other situation. Here you can provide, so this load credential, you can provide like a variable name equal column name in the subscriber table. So once the authentication is required or performed, along with the password, Kamailio fetches many other columns as you configure here, and their values will be in the configuration file after authentication function. We actually fetch the password again, separated and what's used inside, and we store it in AVP password script variable. So this would be like, if you look at the default configuration file, you have route auth, and you can replace it with this route auth cache. The one from the default config file does also IP authorization with permission. I just keep it for the sake, so this would be more or less like in the middle of that default config route auth. So what we do here, first we check, this is a variable that looks in the hash table, SHT. This is the name of the hash table as we define it here. And this is a variable, so and it's going to be used as a key. So $AU is authentication username, Daniel, Ole, whoever registered at that time. And this is a static string that we put here actually. This colon password, it's up to you to use. Only this is like a variable and expanded by using the value from that request processed at the moment. So if it's different than null, that means we have a value, and then we use pv auth check. This is a function from the auth module, which is required by authDB. So it's not new addition, it's why I haven't really put it here. There's no change comparing with the default config file. And now the password is given as a parameter. So we have the realm that we take it from the from domain, the password and couple of flags, which kind of authentication, MD5 and MD5 session, and whether to check if authentication username is equal like from username to username. So these are flags that are documented in the readmes. If this fails, we challenge again and we exit. If we don't find the password in hash table, this is practically what we do now with the default config file. We use auth check. This is going to the subscriber table. We'll fetch the password. If everything is fine with authentication, this variable will be set with the value of the password column. Of course, if it fails, it goes with the challenge, but if it succeeded, so authentication was okay, inside the hash table auth, with the same key, so authentication username and the password, we set its value to the value of the AVP password. And that's it. This is also in the default config file. So practically what we added is this if plus this block. The rest is the same in the auth route block from the default configuration file, along, of course, with loading the hash table and setting the load credentials. And you can apply this for whatever other needs you have. You can have SQL ops to fetch your own data, you cache it for a while, and you check first the cache, and then, if not, you go to the database. The next module I'm gonna talk about would be N3 module. Hash table can be used for any kind of key, alphanumeric, numeric, it's up to you. But if you work with numbers, and we will do a lot in telephony, prefixes, the IDs and so on, might be suitable to look at N3 module because the indexing method is way faster. So it will be, any number will be found in the maximum length, or if you use prefixes, will be a match on a shorter path. So practically with each prefix or number, you can associate a value, and that value is stored in a tree. When you do routing, you can match on this tree. Again, it's faster matching than hash table, but somehow suitable only when you have a limited dictionary. So like numbers, they can be only digits, maybe plus or a few other characters. But if you put the entire ASCII table, trees are no longer that. They are still optimized on searching, but they require a lot of memory because each node typically has many slots corresponding for each character. You can define again as many trees as you want. You can load values from the database at startup. You can reload later. And again, I use it quite a lot, especially like mapping a DID to a dispatcher group. So this prefix needs to be routed to that carrier. That carrier has a couple of gateways. So I have prefix to dispatcher group ID, and then dispatcher group ID will do round robin based on that, or whatever algorithm you like. So N3 is really good at doing such indexing. I added here because sometimes people need to share some information, and Redis is known to be quite used in the rest of the world, not only in telephony, for caching or fast storage. Even RTP engine, which deals with a lot of traffic and so on, relies on Redis to do high availability of the media streams. Andreas Grenning will present a bit more about the RTP engine, what they are doing with it, rather good application. And also some other companies for example, they started with N3 as number portability indexing, but then you have a huge amount, and then if you have like 10 Kamailios, updating in a single instance will require reloading, and then you actually have to do for each of these instances. And then accessing from external, like updating, removing keys from there was a bit too complex to do it on all the nodes. So you can go with Redis somewhere in the middle. There are variants, or not variants, alternatives. Memcached, which I think was first contributed by 1&1, was the initial option. Redis got more popular, or if you prefer other NoSQL databases, we have support for MongoDB and also Cassandra for as a connector from the configuration file. Routing. So there are more like caching inside Kamailio or outside as a suggestion with Redis. Redis, actually, I put here some examples from our configuration file. Again, you can work with many servers. Karsten from NG Voice added also support for their cluster recently. So you can connect to many nodes at the same time and do any kind of operation you want with Redis. We have a CMD command exported to the configuration file. So it's very flexible. Doesn't require to work with a single Redis. You can have one for number portability, another one for some other needs. So again, these are what you see with NDB are NoSQL, and they are like connectors from the config file. They can't really be used by other modules. It's more for you to build a configuration file using them. And the last section I have here, it's getting to optimizing the execution of the routing config. First, on scalability of the application, like how many worker processes, how we call them. So practically, Kamailio is a multi-process application. When it starts, it creates dedicated processes for different tasks, timers, handling UDP traffic, handling incoming TCP TLS traffic, handling SCTP. So per transport layer, we create a pool of processes. Some of the pools are per transport layer, like TCP. Some of them are per socket, like UDP and SCTP. And you can actually do it per socket with socket worker options. So maybe this is more used together with TCP eventually. Also UDP, I use it like I want to start, I don't know, 16 worker processes for my real network interface connected to the phones, and then I still want to have like on loopback, but only one or two because I do monitoring, keep alive sending to Kamailio on the loopback. But then I don't really want to have 1632 or whatever large number for the loopback interface. So if you use socket workers equal 2 before listen, the next listen means, okay, I'll create only 2 workers for this, and is resetting after evaluating that listen global parameters. So that could be good on saving some resources on some sockets that are not that used. With TCP, TLS, we actually do multiplexing there, and we can handle HTTP. So also for some API, I create a socket on, I don't know, port 8080, and I don't really want to have the same number of workers as with the SIP traffic. And then we have the asynchronous worker processes that are used by other modules. So this is also something that you can tune. We have asynchronous MySQL queries. That's only for inserts. So if you want to write something to a database and you are not caring about the result, you can delegate it to a non-worker process. So the routing invite goes fast on, and inserting to the database is taken care by another process that never handles incoming SIP traffic. From the command line parameters, share memory is quite important and private memory. We have our memory manager. You can choose which of these memory managers you want. I think by default we are now FM or maybe QM for debugging. There is an alternative contributed by the guys at Libon. Federico should be around here. Camille, which is a bit more optimized for TLS usage. In some corner cases, the name is just misleading there or a bit overlapping, but the history with the memory manager is the QM and FM, it's more or less the same algorithm. QM keeps a bit more debugging information. FM is more like for production and keeping the lower overhead per allocated chunk. If you are not familiar what means a memory manager, it's like we ask from the operating system a large chunk of virtual memory, let's say 1 giga, and then we do micromanagement inside it. And then we need to keep track what's allocated, what's not allocated, and so on. By that, sometimes it's easier to discover memory leaks, sometimes it's a bit harder. Anyhow, back to the history, QM and FM are the old one, and their target or the initial design was optimized for SIP traffic, as it used to be, I don't know, 10 years ago, where you have invite by in the range of like half a K, 2K. Now I have WebRTC invites with SDP, so then it's way longer. But because trying to optimize for that use cases, so it's very optimized for dealing with chunks less than, I don't know, 8K or maybe 16K. However, TLSF it's maybe not as optimized for this range of chunks, but it doesn't have corner cases because it was discovered that when you, I don't know, have a 500,000 TLS connection, a TLS connection uses a lot of memory, buffers for encryption, decryption, and so on, keeping the certificates, the public, private keys there, and then cutting everything at once. Practically, Kamailio had to free 500,000 large structures, which were not in the optimized range, and then was practically a single list having all this structure, and freeing them was taking a bit, let's say that. With TLSF, you don't get in that issue, and probably we could consider switching to that as a default, given that OLED doesn't allow anyone to run UDP anymore, only TLS and IPv6. Anyhow, you can choose it at startup, so you don't have to recompile it like in the past, just use -X, and you can even have different, because you have two types, private share memory. Typically, you just use the same for both, so you use only the -lowercase x, and will take care of setting the private memory manager as well. Share memory size, this is not as recent as choosing the memory manager, but still relevant to choose the size of the memory you want to have reserved per process or per instance. Core parameters related to memory, there are a couple of them that if you don't set them properly can slow a lot, especially memDBG. If you set it to a lower value, you will get a lot of noise in the syslog about memory operation for each allocation, the allocation, couple of logs there, and each action is probably doing a lot of operation with memory. So that can fill your log very fast. Memory join and memory safety. So joining was a bit of a problem in the past because actually fragmentation was a bit of a problem in the past. We added memjoin that will join fragments that are next to each other when they become free, available. Now we try to do it in like a dynamic way. When we discover we don't have any large enough chunk, we'll try to do join, but you can still enable if you want to be on the safety side. Mem safety is more about crashing or not when we discover problems with memory chunks, like maybe you allocate a memory chunk and you try to like free it a couple of times without resetting the pointer to 0. By default was like crashing in the past, because the idea was to discover the problem. But I agree that in production you would prefer rather having like a log message where guys you are freeing or trying to access the memory when it is not allocated. So it might be good to enable that. Going to the next level of optimization. So now it's about modules. A lot of modules create their own hash table by themselves, not the module itself, but like TM module keeps the active transaction in a hash table, creating only for that purpose by the TM module. User log does the same. So if you have 1 million users, they will be in a hash table inside Kamailio memory, optimized for the location services. Same with dialog and a couple of other modules. I'm not focusing on all of them to list them, but what's important, look at these modules you are using in the README. It's important to look at the README. And if you see a hash size parameter, that's practically something that you can tune. So especially for user log, if you have a lot of users, so I don't know, large deployment, probably you will need to increase the number of slots. The balance, of course, is between allocated memory for the head of the slots, but if you have a lot of users, that is not. If you estimate to have, I don't know, 100 records, makes no sense to create a hash table with, I don't know, 16K slots. But if you have 1 million users in location table, then makes sense to have a large hash table. TM doesn't have, as far as I know, because it creates one with 64K. We said for transaction we need to create enough for the users. Another thing that you can tune for performances will be the timers. Most of the modules that need a bit of timer operation, including user log, like scanning for expired location records, by default they use the core timer. But if you have a lot of records or a lot of modules using the core timer, then practically it's getting a bit overloaded. We added to most of the modules an option that they create their own timer processes, and it's good to do that for like user log or even hash table, because we have this auto expire, so we need to scan for expired records. If you expect to keep a lot of records inside these modules in the memory, create or configure the modules to create their own timers, including this not helper to send keep alive for keeping the pinhole open. So again, hash table sizes and timers. Look at your modules that you are using. If they have, think if needs to be tuned a bit. On the routing logic, this is more like some hints that you need to do. Of course, detecting attacks as early as possible, otherwise you're going to use a lot of CPU cycles to detect. I have to reject this traffic. As well as what I call here garbage traffic. There are a lot of devices sending keep alive themselves, like notifies of options. You can simply just send them 200 OK even without authentication. It makes no sense to do authentication if you detect it's just a keep alive. Detection of the retransmission, it's also very important. We've been working in the last years to have a new method, and if you are not using pre-check trans, then you are not using the new mechanism. Look at it. Also, this is the part from the config file. The vel at this moment, the stable is more or less the same. So it's using pre-check trans along with check trans, the old single line that we use for retransmission. This is not creating the transaction, because transaction is a large structure in memory. You can create it by default with 12 outgoing branches, so we have one incoming invite with all the attributes stored in shared memory, plus structure for 12 outgoing branches by default. You can now tune outgoing branches number, is no longer hard-coded, it's a module parameter. But anyhow, a TM or transaction structure is quite big. By using pre-check trans, you avoid creating that and you still detect retransmission. And typically the transaction is created by T-relay, which is more or less the last action you execute in your config file. So by detecting at the beginning of the config, or as much as possible at the beginning, after the attacks and so on, then practically you avoid running the config file up to the end. T-relay will detect, oh, I already sent out this request, I'm just discarding them. So by that you get also some performance enhancement. Then authentication and authorization, do it before any other expense operation. Typically database and DNS operation are sort of blocking or could take time. Okay, authentication authorization could involve database operation, but that should be the first one. You know, like I'm trying to see, is this user enabled? Yes, okay, go further and then authenticate it, because maybe he's not a good user. You query the database and then you discover the user doesn't have the right password. What you can do with the modules, so there are about the internals of the modules or the logic in the config file now, optimizing or re-architecting your configuration file for enhancing the performances. First would be delegation of execution of a task to another process. As I said, logging or maybe just inserting records into the database for, I don't know, statistics, analytic purposes. You can delegate it to another process. The first option we had was MQ message queue, which together with R timer, you can create timer processes to execute routing blocks on an interval recurrence. And I have some example. If you look on the web, I had this like sending Twitter notification from Kamailio configuration file when you have like a missed call, so sending you a direct message DM, a Twitter DM. This is delegated to another process because you don't want to really block the SIP worker process until Twitter is accepting your request or not. So we delegate this Twitter HTTP request to another Kamailio process, which is never in charge of routing the SIP. Later we added async, which can do more or less the same operation by executing a route block in another process. You will have to set that async workers to the core, and this module will delegate it, the execution to that. Again, it's a lot of situation where you do this kind of recording of the events doesn't really, or they don't have any impact on the next hop selection. It's just for you know, monitoring or statistics and so on. Or delegate the execution to another application. So you can use here AV API, Event API, where you can connect to Kamailio and then get some JSON formatted events, and then you can reply back, and Kamailio will pick it up from another worker processes and will route it there. RT-JSON is typically good to use in this because this defines a JSON format where you can say next hop attributes like request URI, destination URI, from header to header, additional headers. So you can push back to Kamailio in the format expected by this module. And this module then offers you the function to push it as next hop address or push it as parallel forking branches. So you can do serial parallel forking by returning to Kamailio a specific JSON format. How you interact with your application, again, AV API, HTTP async client. Federico is here, so you can do, if you need more explanation about it. It's asynchronous HTTP querying. JSON RPC C, so JSON RPC client. The guys at FlowRoute developed in the past, so they are also around here. Maybe not the initial developer, but they can eventually help. They use net string format, but also in asynchronous. That means just push it to an additional process, and the SIP worker is continuing the routing. And the typical message buses, message queues like RabbitMQ, quite popular, and recent NSQ could be used to send the traffic to another application and then get some feedback. So actually the example here is delegation of insert to custom database table call activity. So we use MQ and RTimer, the first solution I proposed. It's loading the modules. We define message queue. We choose our name. I put SQL, but it's up to you. You can define also many message queues to communicate between Kamailio processes. And then the RTimer. So the timer has two parameters here, the interval and the name of the timer. And the second one will be the exec. We say which timer to be used, TSPL, and what to execute, route from queue. In your SQL ops, of course, to connect to the database and do the query. This is to be executed typically from the request route. So when you have some SIP traffic that you want to keep a log of that activity, but instead of doing the query to the database, we push it to the message queue SQL. The key is not relevant here, but I'm using the from username. So the message queue works with items key value. And the value is the second parameter, which is actually on 2 lines. The variables will be evaluated, so will be for the current SIP message process. And the timer will pick it up from the queue in this route block. So we'll fetch it from the queue name, and then we just execute it, the connection ID from SQL ops. And now we take only the value. So practically it will be this, from the insert to the end, with the variables already expanded by the other process, because this timer process doesn't see that invite. And it's just executing the query. Of course, you can create many timer processes to fetch from the queue. This is like safe to fetch from many. We use synchronization there, so you can have as many RTimer fetching from the same queue as you need, depending on the traffic. So these are actually the tips and tricks I wanted to share with you these days. Probably there are a couple of more that you can look at, but they are more specific for different situations. I wanted to provide the generic ones that are kind of common to every configuration out there. Yeah, thank you for listening. I hope to have some useful information provided today. And now, questions if you have. Okay, questions. I have one here. I'll get it.
Thank you. What is average amount of shared memory per one TLS process? Because some time ago this question was asked, but I searched for it and have not found it.
Yeah, I don't have an exact figure now to tell you, because most of the people are using now the latest algorithms, this for privacy algorithm, which require a lot more. Actually, I can look here. For the past, it was Jan, one of the initial developers of Kamailio. Okay. So if you look at Kamailio, I think it was green oil. I don't use this.
Yeah, you took scroll now.
Okay. Let's agree on evil Google.
You just agreed to pay 10,000 euros.
That was, I don't have change, but tomorrow. So here is the article on Kamailio website, so you can actually search on it, but lazy guys just use Google. And then I think we cache it somewhere. So this was done by the Columbia University, which is in New York, USA, and they try to measure how much energy is consumed by a signaling server. And the guys are using TCP and at some point TLS. And if you look inside the green void particle, hopefully it's still cached on Yannianak's article. Is going here, how green is this one? Anyhow, at some point here's some numbers here. You'll just have to look at it. If I remember at that time was around starting with 64K, depending again, algorithm, key size, and so on. Again, just go and search for green VoIP, Kamailio, and you will see that. Maybe, I don't know, Federico might have a bit more figures as they tested, but approach him during breaks when they tested with, or ask on Kamailio mailing list, because these guys are there every night. I saw them from Transylvania and don't speak, but some of the guys on mailing list are answering now faster than me. Okay, so hopefully I was like giving you the right.
Okay.
If you really want to measure that, the way to measure, because there is a bit of overhead at the beginning with the initial structure, the typical way I do it for anything is like, let's say take it with the user location records. I load 100 registration, I take the snapshot of how much shared memory it's used, and then I put another 100, and I just measure the difference. So you can do the same, open like a 100 connection, another 100, and see the difference of statistics. Other questions? I have Miko there. You should answer the question, not ask me.
So if I use that password caching earlier, are there any safety requirements if something like heartbeat happens? Is it different than with the normal authentication check, or if I load the password into the ADP variable?
Yeah, so that was with plain text password, but you can keep it in the hash mode first, so that's recommended. HA1 form, if you know the configuration file, is the same. You just have to provide another flag to the PV auth check, saying now it's a HA1 form. More than that, it's, if it gets access to the database that's locally, then it's like also getting access to memory more or less. So, there is no extra protection than hashing the password, and that's the recommended way. You can also remove as you want from the hash table, so from like command line if you want. So like when you change the password, you can correlate it with an RPC command, so you don't need to really wait always for auto expire to happen.
Are you going to send me some
pictures?
I'm using this Redis, NDB Redis module.
Yeah.
And I find it creates quite a lot of TCP connection to the Redis database. Is it hard-coded, or can I control the number of the connections?
Well, normally it should be one connection per Kamailio worker. So if you start many workers, that's the same also with the database. And so, like going to Postgres or MySQL would be a connection from each Kamailio worker. And that should be for the Redis as well, a single connection. I saw that Karsten added some Redis cluster support with multi-node addresses and so on. There might be more than one because it needs to go to more nodes. But probably you can ask him. I was using it only with a single Redis server, not providing the range of addresses. But again, the default one should be one Redis connection to the server per worker. If you define many server addresses, even if it's going to the same server but a different database, then could be a second connection. So again, to be more accurate, it's a single connection per worker to the database. So even to MySQL, if you connect to Kamailio database and to Asterix database, even they are hosted on the same server, will be a different connection ID.
I thought it was just a single IP, but I saw quite a lot of connections.
Yeah, because we create many worker processes. So each worker has a connection to MySQL, to Redis, to whatever they need. But If you have many modules needing that connection, it's not like each module will open a new connection. We'll reuse the one from the worker, from the process. But again, Kamailio, it's one application creating many processes. If you do a PS, grep Kamailio, you will see a lot of them. If you do chemctl PS, you'll get the list and the description, the role of each process of that instance. Other questions? If not, I think for today we are ready to finish. Once again, big thanks to our sponsor making the event happening again. Floral, Telnix, SIPY, SIPGate, OBI. I have all the names here. We appreciate the help. Tomorrow, don't party that much. This evening, gonna start early. Everyone is pretty much registered, only 40 or 30, 40 still registering, so it's not much time to lose at the registration, and we'll start sharp 9 with a bit of introduction, a bit of history, and looking at what we are doing now and in the near future. And then we go into different use cases by Kamailio, Asterix, and many other projects or technologies. And again, tomorrow evening, a bit of beer, finger food, and wine around here, so we can socialize a bit more than the usual. Lunch provided here, buffet, so you don't really need to plan anything. Will be proper food provided tomorrow, so you can also interact. Don't forget about those people out there to look at what they have to demo to you. OBI, Telnix, the guys from Digium will bring their shiny new phones. Carsten Beck is willing to show their IMS platform, and will have the focus coordinator dynamics showing you access to 4G, 5G networks. So they will be there tomorrow. And besides this, prepare your dangerous demos, I guess. James will hunt you tomorrow. If you don't register, they'll try will hunt you for dangerous demos. If you have questions, we'll be around for a couple of more moments. Be sure you don't forget your belongings here. This is going to be locked, but we'll be cleaning stuff coming and so on. Please take care of your belongings. Thank you again. See you. Okay, as I got a few questions, the presentation will be online. The slides also I'll hand the other speakers, but mine will be there. And also the videos, recording should be available, so if you want to review it at some point, it should be